All right. Hi, everyone. I'm Jeff Bigham. So I am from Apple and from Carnegie Mellon University. And it's my great pleasure to welcome you today to the VizWiz Grand Challenge Workshop and these opening remarks. So just a very short backstory about VizWiz. So VizWiz was this that we created about 15 years ago now. It was an iPhone app, and it let people who were blind take a picture, speak a question they'd like to know about that picture, and then very quickly crowdsource answers to those questions. And over the 15 years since then, so many things have happened. So obviously, computer vision has progressed substantially. When I first kind of pitched this to people in the computer vision community, they're like, well, that's really great, but this is way too hard for us to even start to think about solving with computer vision. That's, of course, now changed. We've now had this is our fifth workshop at computer vision conferences and engaged a huge community of people who are working on this really important problem. We now have many crowdsourced solutions. So we have Ira, we have Be My Eyes, others that are kind of pushing that out. All of this stuff is really great. And so today we both kind of celebrate the successes and also look forward to what comes in the future. And so what are the goals of this workshop? So one is we want to identify current research and application issues for vision-based technologies for people with vision impairments. We want to track progress on data set challenges built using visual data captured by people with visual impairments, and facilitate getting those technologies out from research into products so we can have impact that way, and then also maintain a community around this work. And so I think that's really important. We have 3 invited speakers today, and the tradition of the VizWiz workshop is that we have speakers from 3 main stakeholder groups that we invite. First on the slide here is Eric Wong from the University of California, representing sort of the computer vision research community. We have Thomas Reed, who's an audio producer. Read My Mind, you should check it out, who is representing our user community. We have Horan Chi, who is a software engineer at Google, representing our industry or product communities. And we really believe that at least these 3 stakeholder groups are vital for having impact and making progress in this really important space. And that's something unique, we believe, about our workshop here. This year, so again, it's the 5th one. We had 45 teams compete on our data set challenges this year. We had 11 teams on the Salient Object Detection Challenge, 9 teams on the Few-Shot Object Recognition Challenge, 12 teams on the Visual Question Answering Challenge, and 13 teams on the Answer Grounding Challenge. And so you'll get to hear a little bit more about those challenges and the teams and our winners later in this workshop. Very quickly, our schedule. So we have 3, as we mentioned, 3 great keynote speakers. Eric's going to kick us off right as soon as I get done talking. Then we'll talk about the VQA and VQA grounding challenges winners. We'll hear from Horan Chi, who is the lead for Lookout at Google, building an app for blind and low vision people, challenges, and opportunities. Then we'll hear Few-Shot Object Recognition Challenge winners. We'll hear from Thomas Reed, when AI is access and independence. We'll hear from the Salient Object Detection Challenge winners. We'll have a QA panel with our 3 invited speakers, some open discussion, and then a poster session, and see how we're going to fit all of that into the next 3 hours and 37 minutes. It's going to be action-packed, so stay tuned. Okay. Also wanted to acknowledge, we are in Canada, but in the US, this is the Juneteenth holiday. So this is a US holiday commemorating the end of slavery in the US. On this day, the Union Army arrived to the last state in the Confederacy with institutional slavery, that's Texas, in 1865 to proclaim freedom for enslaved Black and African Americans. And so I want you to please join us in commemorating this day. Our organizers, we have a really great group of folks that have been organizing this for several years now. Really leading the charge is Donna Garari from the University of Colorado. I'm Jeff Bigham, Carnegie Mellon Apple. Ed Kuchel from Microsoft. Changyan Chen from University of Texas Austin, who's here organizing. Really, Donna is the kind of mastermind, and Changyan is the one that made everything happen. So, and Daniela Meschetti from Microsoft, Abigail Stengel, Samreen Anjum from University of Colorado Boulder, and also making everything happen, Yuyun Sin from University of Colorado Boulder. And so the 3 of us are here So please feel free to reach out if you'd like to help in future workshops. And then finally, it's my great, pleasure to announce or to acknowledge our sponsor, which just happens to be the company that I work for, Apple. Apple is able to fund this event and make it possible. All right, so let's get started with our jam-packed agenda. And I believe Kangyan will be introducing Eric.
Thank you for all coming to our workshop. So next, I will welcome Eric Xinwang for his speech. Xinwang is an assistant professor at UC Santa Cruz. His research focuses on building embodied AI agents that can communicate with humans to perform real-world multimodal tasks. Welcome, Professor Xinwang. Hi. This is for me.
Hi, everyone. Good morning. And I'm very glad to be here today to talk about my research on building generalizable, scalable, and trustworthy multimodal embodied agents, which I believe is very relevant to the people with disabilities. And okay, let me adjust the screen a little bit. It's blocking my slides. Okay. Nowadays, everybody is talking about ChatGPT, right? A large language model that is trained by OpenAI that can do lots of things for us. But you may also know that it has some certain limitations like fact hallucination. And today, let's ask ChatGPT a different question. Can you navigate to the vending machine and use my credit card to get a drink for me, right? And we can imagine that if ChatGPT can do this, then it would be very useful for people with disabilities, senior people, and the general public. Right? But the truth is that ChatGPT is unable to physically interact with the world or perform any actions outside of answering questions and providing information, because it's purely a text-based conversational AI and does not have any abilities to navigate or interact with objects in the real world. And this is where multimodal embodied agents come in. Right? And today I would like to talk about my research on building embodied agents that can see the visual world through their eyes, talk with humans in natural language, and most importantly, act in the real world. And such embodied agents can do lots of tasks for us, like households, at our home environment, patient care in the hospital, especially for contagious disease, and various tasks in agriculture, disaster relief, search and rescue, among other fields. And today, I'm going to talk about 3 fundamental problems in multimodal embodied agents: generalization, scalability, and reliability, with 3 of my recent works. Okay, we will start with generalization. I will introduce CPL, a counterfactual prompt learning method for vision and language models. This is a joint work among UC Santa Cruz, UC Santa Barbara, and Google. Okay, recently, large pre-trained foundation models have basically revolutionized many fields, including NLP, computer vision, and vision and language, including on both discriminative models such as CLIP, BLIP, and GLIP, and generative models such as DLE, Imagine, and Stable Diffusion. However, those pre-trained models still suffer from poor generalization in many scenarios. So let's look at this example here. We can do a quick quiz. Given the text prompt, a man is catching a frisbee, and those 2 images below. Then, which one do you think match the text prompt?
The next one.
The left one.
Yeah.
The obvious answer, right? However, the CLIP model predicts the right one in this case. Okay, this is the similarity scores predicted by the CLIP model. Higher scores represent higher similarity with the text prompt.
Could you describe the images to make sure that?
Oh yeah, sorry about that. So the left image is basically about a man is catching a frisbee, which is exactly what the text prompt is. And the right image is about a dog is catching a frisbee. Okay, so this is mainly because of the spears correlation problem. So perhaps during pre-training, the CLIP model has observed lots of cases where a dog and the concept catching frisbee co-appear together. And then in this case, when the CLIP model detects the dog in the image and catching frisbee in the text prompt, it will automatically produce a higher similarity score, regardless of the subject in the image, like man versus a dog. So spurious correlation from pre-training results in the poor compositional generalization problem. In other words, because spurious correlation leads to the poor generalization to unseen tasks or unseen combinations of same tasks. Okay, so to overcome the spurious correlation problem, we introduced a counterfactual prompt learning method called CPL to learn more distinguished and generalized prompt representations with just a few examples. Okay, still the 2 images, a man is catching with the corresponding text prompts, a man is catching a frisbee, and a dog is catching frisbee. So we can actually ask what-if questions to learn more generalizable representations. So what if we replace the man in the left image with a dog, or what if we replace the dog in the right image with a man? Then their text prompts would be changed accordingly, right? So the high-level idea here is first construct counterfactuals by identifying minimal non-spurious feature change that causes the concept change. And in this case, the minimal non-spurious feature change would be the man feature and the dog feature. And then given both the factual data we have in the dataset and counterfactual examples we construct, we can learn more generalizable representations. Okay, now let's take a look at how we do counterfactual construction. So by viewing image feature as potential cause of the label, then a non-spurious feature shall be a sufficient cause of the label. So we define a counterfactual visual feature V prime as a combination of the positive visual feature V and the negative visual feature V bar. And in this case, let's view, the man image as the positive image and the dog image as the negative image. And here you can see the coefficient U is the amount of negative feature in this counterfactual. Okay, so here basically the counterfactual feature is a combination of the positive feature and the negative feature, and while the label of the counterfactual would be negative. So we can basically capture the non-spuriousness by replacing essential non-spurious features only. And this can be achieved by minimizing the amount of negative features in the counterfactual. Oh, sorry. So in other words, we would like to keep, the maximum amount of the positive feature and minimum amount of negative feature in the constructed counterfactual, while the label of the counterfactual feature is negative. So we basically only add the essential negative feature into the counterfactual to make its label negative. And we do joint optimization of counterfactual construction and problem learning. And there are three main terms in this learning objective. First, the cross-entropy loss used in the original training. We can still use it for fine-tuning in few short scenarios. And then the counterfactual learning objective, which helps us to distinguish between the factual examples we have and counterfactual examples we construct. And the third term is the counterfactual construction loss, which is basically to minimize the amount of negative features in the counterfactual construction process. And note that the counterfactuals are dynamically constructed within each batch during training. So it's a one-stage optimization problem. Okay, so back to the example where the Clipper model fails, then we can see after using our CPR method to fine-tune the Clipper model with just a few examples, it can do the right prediction now. And we extensively evaluated the CPR method over 10 data sets across the task of image classification, visual question answering, and image text retrieval. And here are the results on image classification. And as you can see, okay, so we compare a CPR with the Clipper model and the state-of-the-art fine-tuning method, CocoOp. As you can see, previous social method, CocoOp, performs even worse than the zero-shot clip on unseen classes. And while our method, CPR, outperforms both zero-shot clip method and CocoOp method on both seen and unseen classes, which demonstrate a strong compositional generalizability. And here are the results on image text retrieval and visual question answering. For both tasks, we only use a small portion of the training data to fine-tune the model. See, only 1% of the training data. And CPR outperforms Clip and CocoOp on image text retrieval and visual question answering by a very significant margin here. Okay, so in addition to discriminative tasks, text-to-image generating models, such as Stable Diffusion, also suffer from poor compositional generalization. For examples here, given those two text prompts, a red car and white sheep, or a blue backpack and a brown elephant, So stable diffusion model would generate some high quality images, but not exactly matching those two test prompts. As you can see in the first example, in the first example, stable diffusion generate a red car and a red shape instead of white shape. And in the second example, stable diffusion generate only a blue backpack. The brown elephant is totally missing in the generation result. And we introduce a training-free structured diffusion guidance to improve the compositionality in text-to-image generation without training non-fine-tuning at all. Okay, so the high-level idea is to first parse the text prompt into some linguistic structure like a parser tree, and then we inject those linguistic structure into the attention manipulation process inside the stable diffusion model to guide more faithful generation. And after doing that, the model is able to generate more faithful images that actually match those two input prompts. Okay, I'm not going to talk about details about this work. This is our recent iClear paper. Feel free to check it out. Okay, a few takeaways. First, pre-trained vision and language models often suffer from poor compositional generalization due to the spurious correlation problems in pre-training. And the CPR method learns non-spurious and generalizable prompt representations for vision and language tasks under few short settings. The structured diffusion method improves the compositionality in text-to-image generation in a completely training-free manner. Both methods are very simple to implement and sample efficient to run. Okay, next I'm going to talk about the scalability. We would like to connect vision and language to actions for dynamic decision making. And I'm going to talk about our new compositional benchmark for vision and language manipulation called VLM Bench, which serves as a tool to measure and develop embodied agents in terms of generalizability and scalability. Okay, in fact, learning how to manipulate an object is one of the last mile problem of embodied agents, while existing embodied benchmarks often simplify this process. For example, if an agent produces a pickup action, the object is typically moved to the agent's hands automatically. So the agent doesn't really need to learn how to rotate its hand and pick up the object in a certain angle. So the object would be magically moved to the agent's hands in most of the existing benchmarks. It's just like the agent push a button and then the object would be in its hands. Meanwhile, existing vision-based robotic manipulation mainly focus on control and reinforcement learning without compositional language understanding. For example, there are usually a predefined set of existing tasks, such as pick up soda can, pick up the star, put tree in oven, put bottle in fridge, and these are generally treated as numeric labels with little consideration for language understanding. And a common practice is to develop an individual policy per task here. Just like the classification problem. And then but in this case, when we observe or when we receive a new task, like put a bottle in oven, right? Even though the action put, the objects bottle and the oven all appear in the training set, this new composition doesn't exist. So the existing policy cannot deal with this task. And so our goal is to tackle the challenge of vision and language robotic manipulation, or VLM for short. And this would allow the robot, to carry out the task based on compositional language instructions. For example, the task pick up the star and place it into the purple container. We want our agent to be generalizable enough to handle similar tasks like pick up the yellow triangle and place it into the green container or the purple container. Since there are no prior benchmarks for this, we introduced a novel compositional benchmark for vision and language manipulation. That meets the following criteria: categorization, compositionality, generalization, and scalability. So for example, the task must be highly categorized enough and composed of diverse unit tasks in order to be generalized to novel tasks or novel compositions of say objects. To do that, we first introduce an automatic manipulation solver for automatic task construction. So in principle, those non-horizontal tasks, such as making coffee or put the plate into the dishwasher, can be decomposed into a sequence of unit tasks. For example, for the non-horizontal task, fully open the dishwasher and take out the red plate, we can decompose it into 3 steps. Step 0, open the door of the dishwasher. Step 1, pull out the tray of dishwasher. And step 2, pick up red plate. So if we can come up with a unit task template to represent all kinds of those unit tasks, then we can easily deal with the compositional nature of this task and further, compose more complicated non-horizontal tasks. So the automatic manipulation solver is designed to do that, to construct the unit task automatically. For example, here, pick up the star and place it into the purple container. We can view, the manipulation unit task as a combination of specific actions and target objects. For actions, they have to follow some motion constraints. Like in this example, the agent has to move and rotate the blue star to stack it on the red star, which shows a goal pose constraint. And in some other scenarios, it may require some path constraint scenario, like wipe the table, from the top left corner to the bottom right corner. And for a more modular and compositional design, we use object-centric descriptors for target objects. Those descriptors cover things like the classes, whether it can be articulated or not, the color, size, relative position, and graceful pose of the objects. Using AM solver, automatic manipulation solver, we create the VLM bench dataset, which consists of over 11,000 automatically generated tasks, while the previous benchmark IL bench only has 100 manually designed tasks. And VLM bench also supports unseen task evaluation, novel object adaptation, automatic 6 degree of freedom grasping, and all of those benefit from the compositional task formulation we just mentioned. Here are some examples of this dataset. These are some demonstrations for categories of Go constraint tasks in term including stack, pick and place, drop pane, shape sorter, with all kinds of task variations in terms of color, size, shape, and the relative position. Here are some examples of the path constraint tasks, including wipe, pull, drawer, and door tasks, with all kinds of variation in terms of color, size, shape, direction, relative position, the amount, and actions. Okay, so to complete VRM task, we propose a baseline agent called 660 clipboard. Okay, so it is at a high level, it is a key point based method, which predicts the key waypoints of the trajectories first, and then connect them based on the robotic geometry. So it takes, the RGB image and the RGBD, the depth information, as the input to the model, and it is based on the pre-trained clip model with a transporter to deal with the depth information, and then we do some sort of feature fusion and use a decoder to predict the 6 degrees of freedoms, including the positional information X, Y, Z, and the rotational angles of the robotic arm. Okay, here are the results. 60 clipboard on our VLM bench dataset in terms of different tasks and scene and unseen tasks. First, both vision and language information play a very important role in VLM tasks. So vision only or language only agent cannot deal with this task well. 60 clipboard achieve reasonably similar performance on both scene and unseen tasks, which demonstrate its strong generalizability. And we believe, the ability of compositional reasoning really matter for further improvement. So you can see for those tasks, the highest success rate is around 20%. But for some very challenging tasks, such as pour water or open door, the success rate is still below 10%. So the VLM task is indeed very challenging, but there are lots of room for improvement. Okay, a few takeaways. First, automatic manipulation solver. We introduced automatic manipulation solver for automatic VLM task generations. That means, we can always scale up. This is a tool, and you can use this to generate more kinds of VLM tasks, more complexity. We then use AMS solver to construct a data set to benchmark the progress of VLM agents. It is a testbed for compositional reasoning, language grounding, and reinforcement learning, among others. We also introduced a baseline agent, 60 clipboard, to facilitate future development of 6 degrees of freedom robotic manipulation following human guidance. Okay, so for now we have covered, generalization and scalability of embodied agents. Let's now quickly talk about another important aspect, reliability. And this is a ECCV 2022 paper, Fed VRN, privacy preserving federated vision and language navigation. So navigation is actually a core skill of embodied agents, right? And the task of vision and language navigation is to navigate an agent by following human natural language instructions provided by humans. For example here, we might ask a home assistant robot to pick up the plant, to grab the plant for us, and may provide some fine-grained instructions, such as get out of the room and go towards the kitchen. The plant is on the window near the kitchen. So in order to complete this task, the agent must, understand both natural language instructions and the dynamic visual environment and the reason about the actions to take step by step. However, existing VLN, vision and language navigation methods, all concentrate on centralized training. That said, all the training environment and the data would are scanned and uploaded to a centralized server, and then we train the models on this centralized server and deploy it to the testing environment. A major issue with this approach is the data privacy problem, because then the server would have access to all the training environments, and in this case, it would be our host environments. And even worse, if we deploy the trained agent onto the testing environment, and still want to optimize the agent maybe in a continual learning way or lifelong learning way, then the agent would observe all the sensitive information in the house environment, like human activities or the layout of your house. So we would like to introduce FedVLN, Federated Vision and Language Navigation, the first privacy-preserving federated learning framework for embodied agents. So rather than centralize everything onto the server, we can decentralize, the training into different house environments. So basically, we view each house environment as a separate client and deploy a local agent within this client. And then we only update the local model parameters to the server for model aggregation. So there would be no data sharing between the clients and the server and between different clients. During the training stage, we share the complete local model for aggregation, including the language encoder, the trajectory encoder, and the actual decoder. This is a typical non-IID problem, because the local agent can only observe the local data of a certain environment. So a primary challenge is to maintain strong navigation performance, right? Because it's challenging to train a local agent without the loss of generalization. So our FedVLN method managed to achieve comparable navigation performance to centralized training methods here in terms of different navigation metrics such as CLS, SPL, and success rate. And after deploy the agent to the new environment, we also propose a federated pre-exposure method to continually improve the agent while preserving the data privacy of the testing environments. So given the limited time, I'm not going to introduce the details of this, but here we surprisingly found that the federated pre-exploration can even perform better than centralized pre-exploration and environment-based pre-exploration, like two state-of-the-art methods for pre-exploration. So the key takeaway here is that we only upload the language encoder for model aggregation, and you use the trajectory encoder and actual decoder to adapt to the local environment. That actually helps a lot. Okay, so first, privacy and security in embodied agents are very crucial, but often overlooked. We introduced the first federated learning method for privacy preserving embodied agent learning, and we strongly believe that researchers and practitioners should prioritize those aspects to create more trustworthy embodied agents. Okay, thank you very much. And all the data, code, and models are publicly available.
Everyone, my name is Cheng Chen. In this talk, I will discuss our VizWiz VQA challenge. Here is the outline for this session. I will first introduce the VizWiz VQA dataset and the task, describe the challenge, announce the winners, and finally present the analysis of this year's results. So the task is to answer visual questions from the people. Here are a few examples. Although these visual questions may seem trivial to answer for many of you, they can pose significant challenges for individuals who are visually impaired. And here is how we split the dataset. Our VizWiz VQA dataset contains around 20,700 visual questions from the training set, 4,300 for the validation set, and 8,000 for the test set. The evaluation matrix is the same as the accuracy measure used in the VQA-V2 challenge. The computer score of predicted answer to each question is matched with the number of humans that responded with the same answer. Now we are going to announce the winners for the VizWiz VQA challenge this year. The second place is Big Blue AI. Here are the team members. They are from Big Blue Technology. Congratulations. And the winner is Hang Zuhei Ting. Here are the team members. They are from Xidian University. Congratulations to both teams. Over the past 5 years, we are very excited to witness a huge progress in this challenge. This year, 12 teams participated in the challenge and received very impressive results. Overall, we find that the top 3 teams performed best on visual questions requiring higher recognition skill and performed worst on visual questions requiring text recognition and counting skills. And here I show some examples where all top 3 teams provided incorrect answers. We found that algorithms might struggle to answer visual questions involving blurred text, long-tail object, and those requiring reasoning and counting skills. And now we're going to play the videos from the winner team. This is the video from the first place.
Everyone, I'm Xiaoqian Lu from Xidian University. It's my honor to present the method answer region guided VQA based on visual language pretraining, which we use during the vision question answering challenge text of the VSWZ Ground Challenge workshop. This is our team information. We are a team from the K Laboratory of Intelligent Perception and Image Understanding of Ministry of Education, Xidian University. A VQA system takes inputs as image and a free-form open and the natural language question about the image and produce a natural language answer as output, which can help large people understand the world. Recently, large-scale vision and language representation learning has shown promising improvements on various vision language tests, as shown on the left. The visual language pretraining framework consists of an image encoder, a text encoder, and a multimodal encoder, As an image-to-text matching laws and a masked language modulus are applied to the multimodal interaction between image and text. Different from exciting methods that formulate figure as a multi-answer classification problem, figure-based Boolean language pre-training consider figure as an answer generation problem, as shown in the upper right. The autoregressive answer decoder receives a multimodal embedding through cross-attention. A style of sequence token class is used as the decoder's initial input token. However, since the input of the image encoder is the whole image, this introduces some irrelevant information. A common method is to extract the object from the image field of pre-trained detector, but it identifies all possible objects in the image, and some of them might not be relevant to the text. Thus, we propose also region guided figure specifically the first input image, question and answer pairs to a reference image segmentation model, and then get an output containing only the answer region. Finally, we input the image and its corresponding answer region into the image encoder, and then input the output of the encoder into the multimodal input after calculation. In addition, the types of problems in the training dataset are unbalanced. Therefore, expanding the VizWiz dataset by selecting image text pairs with the same answer from the figure B2 dataset, and at the same time equalize the distribution. Finally, we example the model based on the principle of the minority is subordinate to the majority. Experiments have also proven that our method and tricks can indeed improve accuracy. We use elbow, XBLI, and OFA as our baseline. After adding additional training sets, the proposed auto region guide strategy and the model example will achieve the 64.72 in the test challenge phase. Thanks a lot for listening. Hello everyone.
Now I will play the video from the second link.
Hello everyone, I'm Xiaoqian from Xinjiang University. It's my honor to present the method answer region guide.
We are honored to share our methods in this presentation. Our team has 2 members in total. Team leader Jipeng Luo and member Jiahui Wang. As shown in the left figure, the data for this task consists of photos taken by people with visual impairments and the questions they want to ask. Each image question pair is labeled with 10 answers from the public. The training set consists of 20,523 image question pairs. The validation set consists of 4,319 pairs, and the test set consists of 8,000 pairs. These data points are also categorized into different types, including unanswerable, number, yes or no, and other, with varying frequencies of occurrence. The competition consists of 2 tasks. The first task is to generate answers based on the given image and question, and the evaluation metric for this task is average accuracy. The second task is to predict answerability of image question pairs. And the evaluation metric for this task is average precision. After an extensive survey on multimodal papers and comparisons, we chose BLIP2, bootstrapping language image pre-training with frozen image encoders and large language models as our base model for fine-tuning. The figure shows the pre-training process of the second stage of the model, which is the part we need to fine-tune. The GPU we used for training was V100. However, the whole model cannot fit into 32 GB GPU memory. We then tried to split the model to multiple devices using Hugging Face Accelerate library and run fine-tuning, but the training speed is quite slow, since only one GPU is working at any time. Therefore, we later used the LoRa approach to reduce the GPU memory needed for fine-tuning. This method greatly reduced the cost of model fine-tuning and also yielded good experimental results. For the first task, we used the most frequently occurring answer as the label. The input for the model is the question-answer pair, together with the image, and the model is trained as a sequence generation task. We tried a total of 4 different pre-trained models, which were BLIP2 OPT 2.7b, BLIP2 OPT 6.7b, BLIP2 OPT 2.7b, COCO. This table shows the scores of the best individual model we trained. In our preliminary experiments, we found that the BLIP2 model with OPT as text encoder usually performs better than T5. The BLIP2 model with 6.7 billion parameters has a higher score on our validation set, while on test set, BLIP2 2.7b performs better. For the second task, we modifying the input prompt as shown in the example and setting the labels as unanswerable and answerable. However, during tokenization, these two words were split into tokens of different lengths. To address this, we came up with the idea of replacing the above two words with yes and no. This approach allowed us to calculate the score using the probability of a single token, ultimately increasing the average precision to 82.51. In the end, we trained 20 models under different hyperparameter and random seed conditions, and generated the final answer by taking the average of the predictions from each model through an equal weight voting scheme.
So next, I will discuss our VizWiz replay programming challenge. Here is the agenda. So the task is called answer grounding, which aims to teach computers to automatically find the visual evidence in an image that indicates the language answer. Here is how we split the dataset. The VizWiz VQA grounding dataset contains around 6,500 visual questions from vision set, 1,100 visual questions for the validation set, and around 2,400 visual questions text. The evaluation measures for the VizWiz VQA grounding challenge is intersection of union, which measures the similarity of each binary segmentation mask to the ground truth segmentation. Now we are going to announce the challenge winners for the VizWiz VQA grounding challenge. The second place is MongoTV. Here are the team members. They're from MongoTV. The winner team is UDBIMS Lab. And here are the team members. They're from University of Delaware. Congratulations to both teams. So here is the progress of our challenge. The winning team achieved around 47% improvement compared to the baseline. And we analyzed the results and find out that overall the top 3 teams performed worse on questions with more returns. And perform tasks for visual questions requiring color recognition skill and for some visual questions and requiring text recognition and counting skills. Yeah, so
Greetings, everyone.
then I will play the videos from the winner team. I think they are here today, so if you have any question, there will be a short question and answering section after I play this video.
Greetings, everyone. I'm Ali, and today I will introduce you to our approach titled Embedding Attention Blocks, designed specifically for the VizWiz Answer Grounding Challenge. This work is a collaborative effort between myself and Professor Chandra Kambabatu. We both represent the VIMS lab at the University of Delaware. Current attention-based methods suffer from one of the following three problems. The attention mechanism is not based on a well-known and well-tested method. The complicated design makes it difficult to re-implement them in other platforms, and the custom design does not allow the usage of pre-trained networks. Our proposed method tries to solve these problems. The squeeze and excitation method is a channel-wise self-attention mechanism widely used in classification networks. It consists of a global average pooling of the input, followed by two linear layers with an interleaved nonlinearity and a sigmoid function. In this work, we present a novel attention module based on the squeeze and excitation method. We start by the SE block and perform the following modifications: changing from self-attention to cross-attention, adding a normalization layer, and replacing the sigmoid function with a softmax. To improve the generalizability, we use pre-trained vision language models. A prime example of such a model is CLIP, which has been trained on a data set of over 400 million publicly available images paired with their corresponding text sourced from the internet. We combine CLIP with the proposed embedding attention block to predict answer groundings. We use CLIP's encoders to encode the image, question, and answer. Next, our proposed block recalibrates the channel-wise image feature maps by explicitly modeling interdependencies between the image feature maps and embeddings. The flexibility of our design makes it possible to use both single-scale and multi-scale image features. For each feature map scale, our embedding attention block is used independently to process the features based on the embeddings. And at the end, all the feature maps are combined to produce the final output. We augment the VizWiz VQA grounding dataset with the text VQA-X dataset to increase the training size. We evaluate our method in the 2023 VizWiz VQA grounding challenge. Our method achieves a mean intersection over union accuracy of 74% and holds the first place in this ranking. And thank you for listening.
Hello, everyone.
I think Ali is here today, so do you have any questions? Could you take something? Okay, cool. Now I will play the videos from the second phase, Monkey TV.
Hello, everyone. Today, I'll present our method titled Transformer-Based Solution in Answer Grounding. Our team from Mangit will outline our competition solution across 4 aspects: task, model, training method, and post-processing. The task objective is to identify the region in an image that corresponds to the answer to a given question. This combines image segmentation with visual question answering, VQA. The VizWiz dataset provides visual images, questions, segmentation maps, and answers. In the training set, all 4 components are available, but in the test set, only images and questions are given. Based on the champion solution of the previous edition, we chose BLIP as our base model. BLIP's pre-training on a large-scale dataset gives it strong generalization capabilities. We further pre-trained it on the VQA-V2 dataset, selecting it for its ability to incorporate answer information during training. We added a segmentation module to the BLIP VQA model, including a transformer decoder and an upsample module. The transformer decoder has 3 stacked layers, and 4 upsampling steps are executed due to the patch size of 16. Bilinear interpolation and conv2d operations are used. D for upsampling. For model training, we used the official dataset and incorporated the VQS dataset. We employed binary cross-entropy loss and answer loss. In data augmentation, we avoided color-related augmentations and used simpler ones like flips, rotations, and affine transformations. The model required more epochs for full convergence, so we trained each model for 200 epochs. We also used techniques like exponential weighted average and pseudo-label to improve accuracy. For post-processing, we used a voting-based model ensemble, which outperformed the soft ensemble approach. Individual models had different hyperparameters, utilized 5-fold data, random seeds, diverse training data, top 3 models, and different architectures. Analyzing the validation set, we found the need to segment different regions based on the question type. Textual regions presented challenges, so we developed a dedicated algorithm. We applied test time augmentation, TTA, and preserved the largest connected component. For textual region segmentation, we used Net++ and our CNN models to obtain candidate text regions and masks. The BLIP model ranked answers based on the question and candidate text regions, selecting the best matching text. The corresponding mask region was chosen as the final segmented area.
And we have videos from researching HS as insert. So I think they are also here today, so you can ask questions after this video. And
Hello everyone, it's our pleasure to share our solutions in the VizWiz Answer Grounding Challenge this year. I would like to give a video recorded presentation of our work in VizWiz Answer Grounding. From left to right, our team members are Ringgang Li, Yaqian Zhao, Hongwei Kan, Zhenhua Guo, Baoyu Fan, Runs Zhang and Xiaochuan Li, respectively. I will introduce our work from the following aspects. VizWiz Answer Grounding dataset comes from the VizWiz VQA. VizWiz VQA stands for a dataset including photos taken by blind persons with 1 recorded spoken question and 10 crowdsourced. The answer grounding task aims at grounding answers to visual questions asked by people with visual impairments. As shown in the image above, the question is asking the relevant brand of the product and the ground truth is just the brand area. There exists a similar task named referring image segmentation. For the common referring image segmentation, the text caption may just be the silver bag and not care about the detailed information on the bag. The text caption in the referring image segmentation has direct link to the ground truth mask area while there exists no direct link for the VizWiz answer grounding. We focused on the answer importance because it may be the anchors connecting the question and the image like the object tags in the Oscar model. Last year, we designed the method directly combining the VQA answers into the MDETR model and achieves excellent performance. which verifies our idea above. This year, as the research for the large language model emerges, lots of multimodal models draw on the reasoning power of large models. We employed the BLIP2 model and combined the BLIP2 with the unannexed model into an end-to-end framework. The experiment showed that the framework can help achieve better performance. The framework uses the frozen image encoder and frozen large language model. Here we use FLUNT5XXL and bridge the modality gap using a Q-former module. The output from the T5 model connects to the unannexed model, a universal instance perception model. Finally, the segmentation map is obtained through the transformer decoder in the image. So the whole pipeline consists of two stages. Firstly, the BLIP2 VQA model training, and secondly, the end-to-end training phase combine the BLIP2 and the unannexed model. We trained the BLIP2 model according to the paper. The pre-training consists of the vision language representation learning stage and the vision to language generative learning stage. For the VQA finituning, the Q-former module receives the question as a condition, such that the extracted image features are more relevant to the question. The training details are as follows. The image encoder is VitGiant model coming from EvaClip and the LLM model is FLUNT5XXL model. The pre-training data is the same as the BLIP paper and the pre-train image size is 224 while the finitune image size is 480. The pre-train iteration is 330K. Batch size is 1680 and the initial learning rate is 5e4. In the second stage, we trained our end-to-end answer grounding model. We employed the pre-trained unitext model weights on the object's 365 datasets as the initial weights for the unannexed model part and used the finituned BLIP2 VQA model weights as the answer generation model part. We replace the output from the unannexed prompt generation module with the BLIP2 T5 encoder output. Finally, we trained the whole model on the RefCoco series datasets and the VizWiz answer grounding datasets. Through the challenge, we summed up the relevant tricks for the VizWiz answer grounding. Firstly, the answer anchors play an important role in the answer grounding compared to the common referring image segmentation. Secondly, when finituning on a dataset with limited size, finituning the model on a larger dataset may sometimes reduce the gap between the pre-training phase and the final finituning phase. Finally, also the most important, the end-to-end large language model can enable emerging capabilities such as visual knowledge reasoning, which greatly boosts the performance. Thanks for watching the video.
Thank you for your time and the teams that participate in this challenge and contribute to our VizWiz VQA and VizWiz VQA grounding challenge. Now, Jeff, could you introduce our speaker, Haoran Xi?
Yeah, of course. I'll use this. So it's really great to see how far things have come in research in just 5 iterations of this workshop. I think that's really exciting. I think it's also really exciting when we put this research out into the world in products. And we have a fantastic speaker up next who will tell us about one of the leading products in this area. So this is Google Lookout. And Haoran Xi is the lead for Google Lookout. I knew Haoran from a few years ago. He's a master's student at Carnegie Mellon University, where I'm a professor, and he got a chance to work. We got a chance to work together on a project called VizLens, which was led by my PhD student at the time, who's now a professor at University of Michigan, An Hong Guo. So maybe this was your start in accessibility. Maybe we'll hear from that. I'll hear from you a little bit about that. And just as a little plug, because I'm really proud that Anhung got this out. If you go to the App Store, you can try VizLens, which is a way to kind of help people with visual impairments use appliances or better kind of get access to spatial information. Anyway, that's not the point of this. I'm really excited to hear about Google Lookout and all the great work that Haoran and people at Google have been doing on this product. So please welcome Haoran.
Thank you, Jeff, for the invitation and also all the introduction. And as Jeff said, my name is Haoran, and today I would like to share some of my experience about building an app for blind and low vision people. And this is a little bit about me. So as I said, my name is Haoran, and I grew up in China. I went to Carnegie Mellon University in 2014 for my master's degree. That's where I met with Jeff. And after graduation, I joined Google, and I keep working at Google till now. And since 2019, I have been working full-time on Google accessibility, especially Lookout. So Lookout will be my first topic for today. And especially, I will be deep dive into the challenges and the opportunities we got when develop this app. Then I will talk about our upcoming new feature, image Q&A, and if time permits, we will have our Q&A session in the last. Let's get started. Lookout. So Lookout is an Android app where we aim to use Vision AI and the phone's camera to help blind and low vision people with their daily routine. We initially launched in 2019 with the functionality like reading text, recognizing objects, and we keep increasing new functionality over time. In 2020, we added the new labels mode and the documents mode. And 2021, we included handwriting recognition. And last year, we added the new images mode. And sooner this year, we will launch our new image Q&A, which we collaborated with Steepman team. And I will talk more about this later. And here is a demo for Lookout. Before I play this, one note is this demo was built on some previous version of Lookout. So if you happen to have the latest version installed, you may see some like naming difference, but the functionality should remain similar. Let's go. Oops.
This is a demo of Lookout by Google, helping people with vision loss explore the world. Here's a user using quick read mode to sort business cards.
Longs Peak, Pub and Tap House, Pub and Tap House. Lindsay better buy 10 drinks, get your 11th one free. Any size, any drink, anywhere. Dutch Bros. The Gypsum Rose Minerals Fossils Jewelry. 303, Furniture, Sunflower Furniture, Mid-Century Modern, American Wood, Danish and Scandinavian Shop Small Saturday, Shop Local, Shop Longmont, Shop Small $10 off.
Now we see the user looking through the history to see all the things Lookout has just spoken. Next, currency mode with a well-framed bill,
US $1
a
bill,
folded in half bill,
US $1 bill,
and a bill mostly obscured by the user's hand.
US $10 bill.
Scan document mode helps a user read a book page.
Move device towards bottom left. Move towards bottom left. Bottom left. Move device left. Hold still. Chapter An Unexpected Party. Hole in the ground, there lived a hobbit. Not a nasty, dirty, wet hole.
Food label mode reads barcodes and looks up product labels.
Annie's Homegrown Extra Cheesy Cheddar Bunnies case of product not recognized. Try rotating it to other sides. Libby's Pure Pumpkin, 15-ounce can.
And explore mode recognizes various objects.
2 bananas. Spoon, scissors, fork.
Lookout also has light level awareness. Here's a user looking for a $20 bill in a
Stop
dark
button.
closet.
Double tap to activate. Low light, flashlight on. US $1 bill. US $10 bill. US $20 bill. Flashlight off.
This has been a demo of Lookout by Google.
Thank you. Not bad, huh? So except for all the functional features in the previous demo, there is one other non-functional feature I want to talk about, which I think is very important to look at, which is on-device. So for all of the functionalities you just see, they happen on-device. On-device means they don't rely on any network connection. You can just run it with Lookout without connecting the network. This has a lot of benefits. For example, it's faster because no RPC, no internet connection, and also it's cheaper. This could be very important for our users who live in some undeveloped country where internet could be very unstable and very expensive. It also provides better privacy. This is also very important to blind people because, blind people, they don't always know what exactly in their camera view. So maybe they're thinking I'm just pointing to a water bottle, which is perfectly safe, but his credit card may be somewhere in the background. So to make everything on device, we provide better privacy. But on device also means we have limited resources, limited to the battery, to CPU, which increase the technical complexity when we implement all of this stuff. And I will talk a little bit more about this in the next session. Now is the challenges and opportunities. we face a lot of challenges when develop this app. Some of them we found some solution, but some of them we still don't know like what is the best way to solve it. But hopefully, with the help of all of you here and all of you in the video chat, we can solve some of this soon in the near future. And I want to start with reading. So Lookout has two modes on reading. One we call text mode. Text mode is designed for reading some like shorter text, like a small paragraph, a business card, something like that. And another one is just called reading now, is reading some long documents. So user can get a full capture of the whole document, then Lookout can read it. So combine these two modes together, they contribute to more than 50% of Lookout traffic, which means this is the most important feature for our users. But still, there are a lot of issues. First is about framing. Before Lookout can read anything, you have to put the text under the camera view, right? But how would a blind people perfectly frame a document? What usually happens is, like, I observed this from a user study session. So blind people, sometimes they put the camera directly on top of the document they want to recognize. Then they slowly move it up until at some point, Lookout starts to say something. Then they just hear it. Sometimes it works, but sometimes it doesn't. So if there's anything like more robust, we can help. And this is our solution. So basically, we integrated a new model, a call detection model, to detect all the edges of the document. And based on the completeness of this code, we can give user some guidance on how to move their camera. You probably already see this in the demo. But when we developed this feature, we had another question is, what is the best way to communicate to the users on how to like move their camera? The most intuitive way would be something like move left, move right. That's what we end up doing. But there are still some issues. In one user study session, what we found is the direction to the user is not always the direction to the camera. So when Lookout tells them to move left, they are moving to their left, but their left may be the right to the frame. So in the end, they are moving actually far away from the document. So this is still some like really hard a question, really hard to solve. And next part is about layout analysis and reading order. So let's assume like we already have a good capture of the document, and we can run OCR to get all the text lines. But we need some way to combine these lines into paragraphs, into pages, and then have an order to read them, right? And one thing we noticed is most of the reading order models, they tend to sort things into columns first, and then read things from top to bottom. This is an example. So for people who couldn't see it, this is like, I think it's an academic paper from some website. And it basically sorted the text into like 4 columns. But with this algorithm, it can get the correct reading order and work perfectly fine. But what if we are reading some form-like material, like a menu or a receipt? If we keep reading that algorithm, what will happen is it will read all the items on the left first, then all the prices on the right, and which makes it really hard to understand this information. So to deal with this, we keep iterating on like training newer like reading order models. Basically, we had a model who can get the more natural reading order of the documents. It works for the academic paper I show in the first slide, and also this like receipt or menu situation. We also make sure like this model can work well when the text is rotated. But still, you can see like in the end of this example, this is still not like 100% perfect, but it's something there. But there is some even more challenging scenario. So in this picture, it's a picture of a magazine. And when you open a magazine, you may notice there is a like very natural curve near the text, like in the middle. because like that's how book works, right? So this photo is probably a good photo you can take for a magazine article. But the problem in it is because of this natural curve, OCR will have a hard time to combine these lines because different words, they have their different angles. And usually how OCR works is OCR will use these angles to determine if they are the same line. But for cases like this, it sometimes will combine like words on different lines together into one line, which makes this information really hard to understand. And this is still an open question, an open challenge we haven't solved yet. Okay, next about product recognition. Product recognition, I think when talking about this, people will initially think of like barcode because it's a very intuitive way to recognize a product. And that's also how we did in Lookout in our like 1.0 version. But we also found some issues with that because, for example, if you close your eyes and I give you a can of beverage, how long do you think you will find the barcode on the can? And I tried it. It usually took me like more than 10 seconds. And sometimes I just couldn't find it because it's somewhere, I don't know, maybe I missed it. So then we were thinking like, can we go beyond the barcode? We don't rely on barcode to make this user experience much better. And here is our solution. So we basically improved our product mode. We created a database of embeddings with the product we can see, the common products. And then in the runtime, we will detect this product and create the embedding and then compare this embedding with our database. We also use this OCR for higher accuracy. And with all of this, we are able to recognize a product within less than 1 second because we don't rely on barcode. But there are still issues with this solution. And the issue is how do we scale? Because as I said, we have a database. But if we keep adding things into this database, eventually this database will grow larger and larger. Eventually, it won't fit on device, right? So probably some solution will be, we will just put some common product to this database and leave the others somewhere, maybe online to do the online lookup. But then we need to figure out like, what do we mean by like common products? Even challenging scenario is, how do we get this to work with shelves? Because when people go to any grocery store or like Costco, this picture is what they already see. So if you are standing in the aisle, you will see a lot of product in the view. And how can I recognize any product in this case? We were thinking maybe we can use like hand as an indicator, but still there are some like trade-offs there, and we are still working on this. And last, the object recognition. So I assume like for people who are familiar with machine learning models, you must be familiar with the PR curves. It's like a balance any developer, any like researcher you have to pick between for your model, right? But the case for Lookout is a little bit tricky because our users, they are like blind or low vision people. And sometimes they don't always have the ground truth. They can either trust Lookout or don't trust it, right? So if we in favor of precision, which means low recall, they will think like Lookout is not speaking enough objects. And if we do the other way, they may think, okay, I couldn't trust Lookout because it gives me wrong signals. And how can we get a good balance between these two? Another thing is about distance. So for example, like you probably have a keychain like in your pocket, and the object recognition model could usually recognize this keychain within a shorter distance. Shorter, I mean, maybe less than like 0.5 meters. But if you take a step back, make the camera far away from the keychain, eventually your object recognition wouldn't be able to pick it up. How can we solve this for our users? Because if they want to look for this keychain, you couldn't assume them to like look for it within like less than 0.5 meters, right? And we also have some users saying like they want the ability to like recognize their keychain, their own keychain, not any keychain. And it's about instance recognition, and we are like working on it now. Okay, so enough for things that doesn't work well. Now let's talk about things that works. Image Q&A. Starting with image mode, as I mentioned earlier, image mode was something we added last year. And the rationale behind that was that, images are everywhere. But alt text is some some comments for that image to describe this image for blind and low vision people. But these alt text, they are commonly missing. So in Lookout, we want to enable everyone to experience images, no matter if they're browsing online or on social media or some images from their friends. Oh, sorry. Yeah, so in image mode, we added 3 functionalities. One is caption. Basically, we will give a short caption of the image. So users will know okay, this is maybe a general view of the city. And then we will run object recognition as well as the OCR to get more information. But then our question is, as we all know, the generative AI is really popular now. How can we make the image mode more helpful with the new generative AI technologies? And here is our solution. So basically, Lookout will generate a much more descriptive caption and to give you a better idea what this image is about. And users can ask their own question by their voice or by typing in a question. And here is a demo.
Okay, Lookout VQA demo. This is a Pixel 2 running on residential Wi-Fi, and we'll be using this photo of a mutt on the beach. There's the ocean in the background, some clouds, and some hills. Let's give it a whirl. So first we're going to share it to Lookout.
In this image I can see a dog is running on the sand. I can also see a ball in its mouth. In the background I can see the water, mountains and the sky.
What breed is the dog?
The dog is a mix.
Does the dog look playful?
Yes, the dog is playful.
Now I can also use this to type in my queries, but I'm going to keep doing voice typing. Describe the ocean.
The ocean is calm and there is a mountain in the background.
Are the waves big?
No, the waves are small.
Let's do 2 more. Are there clouds in the sky?
Yes, there is a cloud in the sky.
Is the beach busy?
No, the beach is empty.
So, not too bad. Thanks very much.
Not bad, huh?
Okay, look.
Okay, so we also face a lot of challenges when implementing this feature. And the first thing is about dataset. I assume people here, you are probably familiar with this dataset. VizWiz is a really good dataset for blind and low vision usage. But we also have to admit, VizWiz is a small dataset compared to the large amount of data we need to train a good the generative AI model. And for the other dataset we found, there are something like this. So in this example, this is a picture of a nighttime street, and I can see the traffic lights and some cars in the street. But the alt text says it's a traffic light in the city. That's it, which is correct. Yeah, there is nothing wrong about that. But for blind and low vision people, this information is just too little. They are more interested into a lot of other details. For example, is this a city or a countryside? Is there any cars or how many cars in the street? And is it daytime or nighttime? So we don't have all of this information with this data set. So which actually increase our complexity to make a good model. Also, there are some things about the sensitive topics and AI fairness about this generative AI model. So for example, what if user uploads some sensitive image, maybe some image about like porn or violence? Probably we don't want to like talk too much about those images, right? Because they are dangerous. But what if this image is from some news photo about war? It could be violence, but it seems valid because they want to know more about this news, right? Also, there are questions about like sensitive questions and subjective questions. Is this person a criminal? Is this person pretty? How should we respond to these questions? And irrelevant questions, like I can share an image of like a door of this conference room and ask the question, who is the US president? Should we answer it? Should we not? Like it's a product decision, right? And last, not the least, is person description. Because person, when you describe a person, it could be sensitive, especially when we're talking about perceived gender. Because in Lookout, it's a very special case. When we are making something wrong, we are like maybe offending people, we are not actually offending our users. We are offending a third party who got recognized in the image. And this is a very tricky situation from like both legal and ethnics. So we have a really good discussion on all of this. And another top why like this perceived gender is like complicated is in most of our data set, our training data, they either say this person is male or female, and it's rarely say we don't know. So after that, with the model will tend to give you like either male or female, but it doesn't say like I don't know, which makes these things even more complicated. And last challenge is about user preference. Because as I mentioned in the like PR curve thing, in the object recognition feature, still we see some users, they said they want to more details. And some people says, okay, it's enough for the details, just focusing on the accuracy. And this preference differs a lot between blind and low vision users. Because for blind people, they don't have any idea about the image sometimes. So they want Lookout to be the one who tell them like, what's this about? And there are some users, they even say like, okay, so if you really have a good model, what should happen is I should get enough information from caption. And I don't need to ask any question by myself because they should be already there. But for low vision people, they probably already have some idea of the image, right? They may be more interested into some details. So they can ask their own question about this, like what pattern is the clothing, something like that. So all of this is really hard, like product decisions when you actually want to make it happen in a product. So here is my personal learning after like 4 years working full-time on Lookout. There is usually a gap between the technology we have and the actual useful product BLV people needs. For example, OCR has been there for more than 40 years, but still now BLV people have a hard time in reading. And it's usually easy to get something done by 80%, but extremely hard to get the other 20% done. So let's try closing the gap. And yeah, that's it. That's all of my presentation. And thank you for being here. And I will be happy to take some questions if you have. Right.
Can I ask a quick question? Yeah, come up to the mic, please, if you can. Yeah.
Awesome. Thank you for your talk. Really cool work that y'all are doing. So from what I understand, there's different modes for like reading or like recognition, stuff like that. Has there been any interest in other users or your team looking to unify all these modes into just a single interface?
That's a great question. So let me repeat that. The question is, have we considered to combine like these different functionalities into one mode rather than keep them into separate mode? Yes, we did. But it's complicated because for different modes, it runs different models. And also remember I mentioned like one of the key feature of lookout is on device. So we want to run things on device. But if we have one mode which runs maybe 10 models, it won't fit on device, right? And it's going to take really a long time. And also from user experience perspective, like when should we announce what? Like in this photo, it probably have both text and objects and people and whatever, so many things. And what is the most important things for our users we should announce? There are like just hard questions. We don't have a good answer yet. So right now we are still keeping them into like independent modes.
Thank you.
Sure, thanks.
And so I wanted to ask you about the difference between working like using having your camera on and taking photos of the world or video versus receiving photos via text or seeing them online. Is there a difference between what kind of caption we want to produce in these two cases? And is it really only in the seconds that we would want to generate a caption?
Yeah, that's a good question. So, so when we initially designed Lookout, we were focusing on the like live modes. Basically, we were using like the video stream as input because we want to help users with something like in their surrounding, like to read this letter in front of me or like recognize this object in front of me. We didn't think too much about the images sent from elsewhere. But after like 2 years, like after we launched our product, we keep getting like requests from our users, like they want this functionality. So that's why we added images mode. As I said, it's added last year, right? And only after that, we started thinking like, how can we make this more helpful? Because this is like a separate use case other than the live camera use case. And that's also why we are adding like this image Q&A feature, and it's gonna be released soon. Yeah, I hope I answered your question. But
yeah, absolutely. And just a quick follow-up: do you feel like data sets like VizWiz, the image captioning part of the data set, and others are more useful for? Are they like specifically designed for that kind of use, the image mode that you're now developing, or is there more types of data that we need to be collecting for that kind of use?
yeah, that's a good question. So the question is about the data set we are using for training this that image and Q&A mode. So as I said, we are collaborating with DeepMind team. So DeepMind, they are mainly focusing on training this model. But from my perspective, from what I know is, VizWiz is the most important data set for this use case because there are just more details. And that's exactly what BLE people need. And they also use some other data set, something like text. I don't know the actual name, but they do use some of them. But they have to do some special tuning for the models for those data sets to make sure they can like meet our needs. So yes and no. Your answer. Yeah. Yeah.
One last question.
Okay.
That's not great. Was a great talk. Did you find a specific situation where your image training model did perform very good or very bad in a like situation? Like for example, like when we don't recognize the traffic lights, it may perform very bad because they're very small in the image. But if you want to recognize something in your hand, it may perform very good because they have visual data. So like do you find those kind of situation, interesting situation, but good luck.
Yeah, that's a good question. So basically the question is about is there any special scenario like our model we don't perform very good? So yes, but I don't have like numbers on those. But one thing is about like text in the image. I don't know if you know much about OCR, but for OCR to perform well, this it has a like minimum resolution of the image. It has to be like big enough for OCR to recognize small text. But for like image Q&A, when we send the image to the server, they usually compress the image and make it them small to make sure that it won't be too big for the network traffic, right? So which also means it sacrificed the text questions because it couldn't recognize all the text on the image. So that's definitely one thing. Like I don't think that the current model are doing really good.
Thanks so much.
Yeah, cool. Yeah, thank you everyone. Yeah, I will.
Again.
Cool.
Next, we will have Emily, who will introduce our VizWiz Future Challenge. Welcome, Emily. Hi, everyone. My name is Emily Zhang. I'm from University of Colorado Boulder. I will be presenting the next two challenges in our workshop. This is the second year we're running the VizWiz Future Challenge, and it was great to see all the great participation from teams. So let's start off with giving some background for the challenge. The VizWiz Future Challenge invited teams to build a teachable object recognizer for a person who is blind or with low vision. And what is a teachable object recognizer? Unlike a generic object recognizer, a teachable object recognizer can be taught or trained to recognize users' personal objects. Teachable object recognizers can learn new objects from only a few samples, or what we call shots here, that users collect. And this challenge is formulated in the following way. First, teams must train their model for the future task. And then the user collects new data for their personal objects. And then the model will learn from these few samples. And finally, these personalized models are evaluated on how well they recognize these new objects in the new real-world scenes. So to mimic all this, the challenge defines a set of trained users, which are used exclusively for training, and then a set of completely different test users, which are used to evaluate the few-shot model. The Orbit dataset, which is a dataset collected by Microsoft in 2021, contains over 3,800 videos of objects recorded by 67 people who are blind or with low vision. And that adds up to around 2.6 million frames in total. And with this dataset introduction, we'd like to proceed to the exciting part, announcing the winners this year. Starting with an overview of the results, we had 9 participation in total, almost doubling the participation from last year, which is great. And the results this year greatly exceed last year's results. So now let's go into announcing the top 3 teams. And the third place this year is Team USTC IAP United from the University of Science and Technology of China. Congratulations. The team achieved an amazing accuracy of 88.29%. Well done, this is a tremendous result. And now let's announce the second place. And the second place this year is Team You Are Right, with an accuracy not too far behind the first place, actually at 92.18%. Congratulations. So unfortunately, you weren't able to contact the team and get their names, but congratulations anyway. And finally, most excitingly, the first place is Team USTC NEP East Fuxi from the University of Science and Technology of China and the Fuxi AI Lab. Congratulations. This team achieved an amazing accuracy at 95.55%. Well done. And we also congratulate and thank all other teams who participated as well. Well done to all. Now, finally, we'd like to share some results and analysis of the challenge for 2023. We were very excited to run this challenge for the second year as part of the VizWiz workshop. And as you can see here, we've made a great gains over the original paper's baseline in 2021. So we're really pleased to see all the algorithmic innovation that the teams are helping to drive. But of course, 100% accuracy on the benchmark is not the only thing that matters if we truly want to realize teachable object recognizers for hundreds and thousands of users to work on. We also need to be thinking about what it will take to actually deploy these models at scale. So to draw out a few directions that stand out, first, we want fast and efficient personalization so that users can teach their models on their mobile phone in a matter of seconds. And secondly, we want fast and efficient inference per frame so that they can not only teach, but also the models can help assist these users in real time. And finally, we want explainable and transparent models to users so that they understand how we estimate models and when they fail. So there are still a lot of algorithmic innovations in the years to come, and we're very excited to see what's coming next. And with that, I will wrap up, and thank you all teams who participated. If you'd like to learn more about the challenge, check out these links. We look forward to seeing more teams innovating in next year's challenge. So now we have 2 videos from the winning teams where they share their methods with us.
Here we present our solution for the few-shot recognition challenge from several aspects. We will show our method and rough experiments to you. First, let me introduce our team member.
It's showing on the Zoom.
Okay. Oh, this one better. Okay.
Here we present our solution for the few-shot recognition challenge from several aspects. We will show our method and rough experiments to you. First, let me introduce our team members. Our team is led by Jun Yu, who is an associate professor in the University of Science and Technology of China. He has worked on computer vision for many years and published lots of papers in international conferences and journals. We also have 3 members from Professor Yu's lab. They are Bingyuan Zhang, Renda Li, Renjia Lu. The right side lists our collaborators from NetEase. They provide technology support and computation for us. Their names are Han Yan, Jiaheng Qi, Sudong Shen and Runs Wu. Few-shot object recognition is a long-standing challenge in the field of computer science, which aims at alleviating the problem of data-hungry traits for deep learning. The common categories of few-shots recognition task are zero-shot, one-shot and few-shot. We call them N-way-K shot in a unified manner. For this contest, we could apply few-shot recognition technology to teachable object recognizer, helping blind people to identify the things that they can't see by using a mobile phone. The dataset we used here is Orbit, the Orbit Benchmark Dataset is a collection of 3,822 videos of 486 objects recorded by 77 blind/low vision people on their mobile phones. 44 people are responsible for training dataset. 17 people for test, 6 people for validation. Here we give some images from this dataset. This dataset is different from other dataset in many aspects. Like videos, random way/shot, blind collectors. But one of the most significant discrepancy is high variation. It includes unbalanced classes, light variation, background variation, viewpoint variation, ill-framed objects, blur. Our baseline method is prototypical networks, which is a method based on metric learning. Its basic idea is that we could learn a prototype or center in latent space for each class using support dataset. Once we have a new query image, we calculate its latent representation and compare it with all prototypes. The label of the nearest prototype is assigned to this query image. For efficient memory, we adopt light to train prototypical networks. That means only partial support images have backpropagation process. As illustrated in the right figure, the red dashed line show the backpropagation. Based on prototypical networks, we utilize more powerful backbones in it. Here are backbone we used. The top left is EVA, it pre-trained model with masked images to regress clip vision feature. The top right is Connext 2, which proposes a fully convolutional masked autoencoder. The bottom left is EVA2, which use more advanced model architecture. The last is BEITV2, which encode the image as discrete latent space. We inference the query image with all backbones and adopt the prediction with the highest score. For training, we also assemble some tricks. Here we list some of them. They are label smoothing warm-up, cosine LR scheduler, grid search, TTA, dataset balance, syncBN, grad accumulation, augmentation. In augmentation item, we adopt color jitter, random crop and horizontal flip. We show some visualization for them. Each of them has contribution to the final performance. The last part is experiments. We train each model on the Orbit dataset many times and we choose the best as the final model with fixed parameters. After that we get 4 different meta-classifier-based prototypical networks. And we also adopt the predicate with higher probability as the final label for the query image. Here display the performance of different model in distinct test data. What we can see is each model has a unique bias, each model prefers some specific test data. We confuse them as the final result. Thanks.
Ladies and gentlemen, I extend my warm greetings to all of you. It is my honor to be invited to this conference. My name is Lai Wang, and I am delighted to have the opportunity to share our team with you. They are Shenshen Diu, Gongpen Zhao, Shuping Yang, and we are from Institute of Advanced Technology, University of Science and Technology of China. Today, I will mainly present the accomplishments we achieved in the VizWiz Orbit Few Shot Challenge 2023. Here is an overview of the content I will be presenting in this report. First, I will briefly introduce the relevant details of this challenge. The challenge entails developing a teachable object recognizer capable of rapidly learning new objects from just a few training examples provided by the user. By recording short training videos of their personal objects, the user teaches the recognizer. Once trained, the system should be able to identify the user's objects in complex, real-world videos with various challenges such as clutter, framing, lighting, and viewpoints. This technology has the potential to impact a wide range of applications, not limited to just the blind low vision community. It can be beneficial and applicable to various user groups and scenarios. Next, I will introduce the Orbit dataset that we used in this competition. Unlike other datasets, Orbit show objects in a wide range of realistic conditions, including when objects are poorly framed, occluded by hands and other objects, blurred, and in a wide variation of backgrounds, lighting, and object orientations. Compared to other datasets, the Orbit dataset has the following characteristics. It consists of video frames, the task is random shot way, and it is exclusively collected by blind individuals. Additionally, the data collection process took place in 2 controlled environments. In the third section, I will provide a detailed description of our experimental setup and parameter settings. Here is a table outlining our main experimental setup, including the GPU model and versions of key libraries. Here is a table outlining the main parameter settings we use for training. In the fourth section, we will provide a detailed description of our experimental method. Firstly, we employed data augmentation techniques to enhance the training dataset. One of the approaches we used was cropping clean images to increase the proportion of clean data in the training set. This offline data augmentation technique aids in improving the model's ability to handle images. In figure, we illustrate the light processing flow for the meta-training phases of ProtoNets. For each meta-training batch B in the query set, the support set images are divided into batches, processed through the feature extractor, and the resulting embeddings are combined. Furthermore, based on our research, we believe that the choice of feature extractor plays a crucial role in this task. Therefore, we selected two feature extractors for training purposes. The first feature extractor we utilized is the Vision Transformer. The Vision Transformer, VIT, is a state-of-the-art deep learning architecture for computer vision tasks. It replaces traditional convolutional layers with self-attention mechanisms, allowing for efficient and effective feature extraction from images. The second feature extractor we utilized is the EvaClip feature extractor. EvaClip is a state-of-the-art deep learning model specifically designed for visual representation learning and feature extraction. Finally, we compiled the accuracies of the models using different feature extractors for the 17 users, and further improved the accuracy through model fusion. So, in my opinion, our method is very effective for recognized objects in few-shot learning scenarios. Thanks for your listening.
Thank you, the two teams, for sharing your methods. Now we're getting into a 10 minutes break, so we will be back at 10:25.
All right, welcome back, everyone. I hope you had a good, really short break, and maybe even someone was able to find the snacks, which I hear are downstairs. So sorry if you missed them. So it is my great pleasure to continue on with our workshop and to introduce Thomas Reed. So Thomas, I first knew of Thomas from social media, all the social medias. But one of the things that he's been doing for a while now is a really great podcast called Read My Mind Radio. And I encourage you all to check it out. It's a place for sharing stories of blindness, disability. And so I hope you'll probably tell us a little bit more about this, but also I hope you all will check that out. So welcome, Thomas.
So today I was asked to speak about three main topics. First, the idea of AI answering these questions from the blind community. So my own experience with that, my interest in image descriptions and video descriptions and how that can impact AI or how AI might help improve that. And then third, my experience or my perspective would be my eyes, the app, and the possibility of Be My Eyes kind of using that data to help OpenAI and improve the model. So I'll talk a little bit about that. So I actually have a favorite out of all of these, and since I told you I'm really into audio description, I guess it's the second one. So I'll probably spend more time on the second one, and I think that's probably more valuable. So because my experience to date with the first one, in terms of AI, my experience with AI, has mainly consisted of what we've been hearing all throughout. I mean, is the basic interactions with asking a single question of AI, right? Because usually my experience is I have something that I need to identify, something in my hand. And I think that makes a pretty big difference, right? Something that I can actually touch and take a picture and just ask it, what the heck is this, right? What is this? What is this something that I need to know about? And usually there's some text associated with it. That's kind of usually been the main way that I use AI apps like no disrespect, Microsoft Sing AI. There's a battle of the apps, but that kind of has been my choice over the last few years, because it works. That's really the main thing. But there are other scenarios that I kind of come across, right? So one of the things is that happens with me. I'll give you an actual example. I might have an item, and this would be an object that doesn't have any text on it. So for example, as if you can see, I'm a bald man, usually by choice. I like to say by choice, but the choice is sort of fading away. But yeah, so for example, I have an electric shaver, right? And it has this little adapter, the cartridge that you shave with, right? Lined up. And occasionally, the shaver is a little old now, so it falls out by itself. And so I might, have to kind of look for it. And so it might fall on the floor, but usually I'll get down and I'll find it. But one of the things that I would love to be able to do is sort of take a picture of it, right? Because sometimes, you need to buy a new adapter. You need to buy a new cartridge. But I don't even remember the name of the actual shaver, the device. It probably says it on there somewhere, but usually, it's kind of hard to read those because it's not really identified. But it would be great to be able to take a picture of this thing and sort of ask questions about it. So not only what is it, I know what it is, but where did I buy this? Where did I actually get it from? How can I get a new one, right? These sort of things. Where can I get a new one? So that's sort of a little bit of my experience there with that, or some of the things that I would want. But then I think I go beyond the idea of where I actually have the object in my possession. So I think about it as on-screen identification. And so we have, my laptop where, if someone, my laptop or my phone, if someone sends me a picture, right, that's a thing that I want to identify, and I can do some of that. But then I also think about the occasions where I'm consuming a video, I'm watching a video, and they may mention something. And let's just say I'm an audio guy, so I like gear, I like musical. I'm not a musician necessarily, I tinker, but I musical gear, love it. I just love it, right? So whether it be a keyboard, whether it be some sort of guitar or mixing device, right? But maybe that will be on the screen, and I want to interrogate that screen. I want to know, what is that? What is that? So it would be amazing, because there's no way right now that I know of, outside of possibly, if it's on television, if I'm actually sitting down watching the television, actually from, I would have to pause it, take a picture of the screen. And then even then, there's probably many other things that are going on that screen, but I want to know more about that mixing board, for example. Tell me about that. What does that look like? Is there a name associated with it? I want to learn more about it. So that's the thing that I think would be amazing for me to have access to that. I'll leave it up to y'all to figure it out. How do you do that? But again, on-screen sort of recognition when I don't necessarily have it in my control to zoom in on a picture, on an item, but I know the item's on screen somewhere, and I want to figure it out. I want to know more about that. Other things are advertisements for me, where an ad might come up, about some sort of clothing, maybe. I'm not that much into it, but maybe it's a clothing item. Or it could even be within a movie where someone could have something on and they refer to it in the film, like, oh, that shirt is great. And I want to know more about that shirt, right? What is that shirt? What does it look like? Go beyond the colors, but what else what else about that shirt? Where can I find that shirt, right? Where someone else sighted might be able to kind of go around and look for it and recognize it when they see it. For me, I would like to really be able to inquire about that. But again, it's not necessarily, maybe it's not even in an ad. It could just be within a television show or something like that. But you want to focus in on it and get more information. Maybe the sizes, the fabric, what does that come in? All of those types of things. I think a lot about infographics. That's all for the last few years, that's kind of been the trend in taking over and exploring data. And I understand the power of infographics because it's a way to summarize data and just make it more understandable. So that's one of those funky areas to me where, you know, I guess you could explain the visuals. You could describe the visuals of an infographic, but that's not, to me, I don't think that's really the purpose. And I don't think that would necessarily convey what the image is trying to convey, right? The whole point of the infographic is that it's really succinct. It really summarizes something. So in this case, I may not want to know that there are, 50 buildings or whatever, 2 buildings in a circle, and then there's an arrow pointing to the right, and then there's something else over here. Because explaining that to me may not necessarily make sense without the context. And so it's a way of summarizing that where I guess I want the lesson, I want the takeaway, I want the summary of what that's supposed to be, because that's supposed to enable me to understand it better and be able to kind of, succinctly understand it and maybe even talk about it. So infographics to me are a real challenge. And how do you kind of think about that and move on with that? Here's a big one. Since I have access to you all right now, I'm going to put in my request. I'm going to take advantage of this situation. Okay, so here's a real world example of something that I think would be fantastic. So I live in Northeast Pennsylvania, and it snows. So until I move out of Northeast Pennsylvania, where I get my house in the Bahamas or something like that, winter comes around, and I know it's supposed to snow tomorrow or overnight. I wake up in the morning, and did it snow? I have no idea, right? The way I would know if it snowed is if I hear a plow coming down the street. Okay, it definitely snowed, and it snowed a significant amount because the plow was coming down the street, it's clearing the street. Other than that, I don't know. But even then, I still don't know how much it actually snowed. What would be fantastic for me, less now, but what would be fantastic to know is how much did it snow? And so sort of breaking these down into smaller components. Did it snow? How much did it snow? Do I need to go and shovel? Because if it's not more than a half an inch, I'm not going to shovel, right? So I want to just know. I want to be able to take a picture or ask some sort of device or have my funky glasses on that can just kind of look out and say, you need to go shovel, right? As opposed to my wife saying, you need to go shovel. Or now she says, I'm going to go shovel because whatever. So that's kind of that additional information that I would love to be able to have access to. If we go a step further, give me a robot that would just know it's shovel. I know it's time to go shovel and clear it up by itself. That would be fantastic too. But it's some of those, that additional interrogation of the data is kind of what I'm calling. So if the amount of snow is greater than an inch, time to go shovel. Identifying people is a real big thing to me. I considered getting something like that what's the security package? The Ring? Is that the name of that? The security package? Where the cameras are set up. And I think the advantage of that is because wherever you are in your house, someone rings your doorbell and you can kind of look on your phone and see who it is. Would that translate into, okay, hey, it's whatever, your neighbor. It's Chuck, your neighbor. I said, okay, I'm not going to go answer that. Something like that, right, would be fantastic. That's sort of a next step, not so much object recognition, right, but person recognition. And would it be able to identify someone from the camera? Those types of things are really, really interesting to me. So that's some of the AI stuff that in terms of recognition that I think about. Again, the big thing for me, and we can talk about that now, is audio description. And so I don't know if anyone is unfamiliar with audio description, but audio description basically is the art of describing in a movie or any sort of visual content. It could be a live Broadway play, it could be a sports activity, whatever the case is, describing what's taking place either on screen or on field or on stage, when there's no dialogue, that would be able to enable a person to non-visually understand what's taking place, right? So you think about watching a movie. How many times are there scenes, whether it be an action movie, whatever it is, where it's silent, but there's something taking place. There's something really important happening that you need to know about in order to sort of stay involved with this film. So audio description is that. And so it's a separate track that runs with it where they actually watch the movie and they describe these things that are relevant for someone to understand. So as I'm actually an audio description narrator, and I'm very big on the idea of blind people being involved in the production. And so I was asked to kind of put a title on this, and my title for this, everything I'm talking about today, all falls under the umbrella of when AI is about access and independence. Because for me, I get the technology, I love the technology, but for me, it's what does that technology do for me, for the community? And I think my goal and my hope is that it would provide more access and independence. And that last one is very sort of, it's different for everyone. Independence means something different for me. You can ask someone who's considerably older than me, what does independence mean for them? And it might just be, I just want to walk out and get my mail. And that's fine. That's perfectly fine. You ask someone who's younger than me, oh, I want to do that, I'll do that, whatever. So independence is very different. But again, to me, that's the goal. So for audio description, blind folks have the right and the ability to participate in the creation of audio description. So myself, I'm a narrator. And so the way that I do that, I have access to be able to read a script, record a script. I have access to all the things I need to do to edit, because most of that stuff now is accessible. Many of these digital audio workstations and all of that. But there's two other places that probably are more challenging. One is quality control. And so that's a person who kind of runs through the script. And that's accessible, right? To kind of just determine, okay, does this language really convey what's happening? What do you take away from that? So as a blind person, I can read a script and tell you, okay, I think I'm going to have more questions about this, because this doesn't even give me an image. So I think I need more detail. But then there's also a part of that where quality control, just like it sounds, maybe there's a reference to, the woman has on red high heels. And it's like, those are not red. So that's a mistake, right? So a quality control person would need to identify that. So that's something that AI could work with, right? Could help and say, hey, wait, what are the color of those shoes when you start to interrogate a scene? So I think there's some possibility that would be fantastic, because again, what that would do is to enable a blind person to independently participate in this process of audio description production, or other processes as well. One that's more controversial, but is happening, is that there are definitely blind folks who write audio description. Now, if I was in some other audience, it would probably go, whoa, but y'all are cool. Y'all get it, right? Because you understand that there's accommodations. Technology is an accommodation. And so the question that folks have, well, how can a blind person write audio description? The art of writing audio description, the art of writing isn't necessarily about seeing, right? If we just take the writing part, it's the crafting, it's the wordsmithing, quote unquote, right? It's generating concise sentences that convey a message. And so the method that folks who are writing audio description and are blind, what they use is, well, they have their own way of accommodating. And some of them use an application like Ira. And Ira has an agent on the other side of that app who can describe, not necessarily using the language that the person is going to use to write, because they're going to make it more succinct and make it fit into a small amount of time, but they may get a first line understanding of what's happening on that screen. And so now they make note of that, and now they know how to make that into a sentence that fits into that team, right? So Ira could be someone. For someone else, it might be, hey, to a friend, they're talking to a friend, hey, come over I'm going to buy some pizza and a beer. We're going to watch this movie. You're going to tell me what's happening. But, chances are, depending on how much beer they drink, it might not be the best description. So, but, again, the writer, the blind writer, is going to take that information and craft it into something. So again, thinking about access and independence, that to me is an area and I know there's some work I believe that's being done around with AI. There's a lot of work that's being done around AI and providing audio description. But to me, the thing that would be great about that is if it makes space for someone who is interested in really tailoring that and really keeping the human factor in the production. Because, I like to think about it that, who's better when you really think about knowing what a blind person needs to know about this film once they know about it than a blind person, right? Because they know the information, they know how it's going to form that image. What would make you see that in your mind? To me, sometimes we get into conversations about a movie and I'll always kind of go back and say, well, when did this movie come out? And what I'm looking for is the date of that movie, because I'm going to compare that to the date of when I lost my sight. And there's many times when I'm like, oh, wait, this is after 2004. So my ability to recall an image of this film is solely based on audio description. That's when I know that's some fantastic audio description, because that image is still in my mind. And it was only because of the AD that made that possible. So again, I very strongly think that the ability for blind people to participate and not only have access, but participate in the way that they see fit it's just a great part of what technology can do. And I want to see that continue with AI. In terms of Be My Eyes, in terms of the app, I haven't used the app all that much. And to be honest with you, and this is nothing against Be My Eyes. I just want to make sure that I'm saying that. Nothing against that. That's probably for a few years when I started to use Be My Eyes, I was kind of like, well, no one's answering. It was like 1 million. I don't know how many they're up to right now, but it was said that there was 1 million volunteers. And it's like, where are they when I'm opening the app? Because it would just kind of ring and I wouldn't get a volunteer. I was trying to take it personally. Just kidding. But I actually, it did work for me. It did work for me a couple of times in a hotel, and I wanted to get something from a vending machine. And so that was kind of nice. I held the camera up and it told me that what I was looking for wasn't in the vending machine. Okay, but that's not Be My Eyes for. But I was asked to kind of talk about my opinion on what I thought about Be My Eyes sharing some of that information to assist the AI. And I thought that was just done. So my interpretation of what's happening and what's been happening is that this is sort of the agreement between software developers, and the blind community, is that we're giving you access to this because it's going to help you. But as we all know, I mean, it's going to help everyone. So we were the best test case. It's sort of how I was thinking. And again, this is no judgment at all. This is no judgment. So the idea that Be My Eyes would share that information to improve the AI, that was just what everybody thought. That to me seems logical, right? It seems logical. However, I guess when I think about the bigger picture with AI and the blind community is, will there be space for the community to participate? Because the AI, we all know, is going to be, if it's not already, a billion seems pretty low at this point, right? Everyone's talking about ChatGPT and how much that's going to make and all that. But I just wonder about the space for blind people in the production of AI, whether it be a coder, just all the various points that there are going to be opportunities for people there. AI and well, Be My Eyes and AI. In addition to that, I think about wow, that just went out of my mind. That's funny. AI and Be My Eyes, again, the blind community sort of participating, the blind community participating in the production, not only the teaching, but in the creation of it. And I think it goes beyond, it really does go beyond just the coders. And I think there's subsets, right? There are subsets to the industry. There are supporting things. I just think there's just a lot of opportunities. And I think it also goes into beyond that, it's just society, because I think, and this, again, this is just my opinion. I was asked, so I'm gonna share it. I think there's a bigger picture that goes beyond sort of the technology. And the technology is fantastic. I love it. It gives us access. But what the technology does not do, and I don't necessarily think it's the place of technology to do this. Let me make that clear, is changing society's views about disability. And I think that's a really big portion of what needs to happen in order for real change to take place. Because what we've been told, and I think what is true, is that the technology can sort of, quote unquote, level the playing field. In theory, I think that's true. But I think the part that's missing is the change in attitude around disability that causes still a blind community to have a 50 to 75% unemployment rate. But we have the technology that would accommodate people. Even like I was talking about with audio description, it's clear that it can be done, but what hasn't caught up is the belief in the abilities of people with disabilities. And unfortunately, technology doesn't necessarily make that clear. And so where AI can end up doing things for people, which is fantastic, that's great. But would it do that? Would it help change the attitude about blindness? Would it help change the attitude about disability? And I'm not necessarily saying that it's your place as developers, but I am putting it out there as food for thought, because I think that's a big part of, at some point as humans, that it would be great to kind of figure out, right? How can this help do that? I don't know. I don't necessarily know the answer, especially as it applies to AI or technology in general. But it's a part that I would love to see, because, if it were true, again, I think that unemployment rate among people with disabilities would have decreased. And unfortunately, it doesn't look like that's happening just yet. But yet we still have way more technology than we've ever had. So I'll just put that out there for y'all. Hope that wasn't a depressing or anything like that, but it's just the reality, and I want to share that as well. So, yeah. So I don't know if we had questions, if there's anything that I can do to answer any questions, or if there's anything that anyone else might want, but I was asked to keep it to about 20 minutes. So if I do that.
Great. Well, first, thank you. We have a quick question or two for Thomas. Come up to the mic.
Hi, Thomas. Thank you for the talk. It was really awesome to hear all that. I did a question about your last point about trying to change like the narrative of society about people with disabilities and employment rates and all that. Is there anything that you think developers are doing that harms that progress? While I would like to play solutions on how we could change that rhetoric, and I'd also like to be aware of anything you think that developers are doing to hinder it as well.
Yeah, great question. So I'm going to expand it, because the first thing that came to my mind is not necessarily around people with disabilities. But I'll put it like this. So there's a podcast that I listened to, and this was interesting. And I won't name the podcast app, but in the app, the image was interpreted as follows. So the podcast is Questlove Supreme. So if you know Questlove, the drummer from the Roots, if you know him, he has a pretty big afro. And so the image said a man with a helmet. What? So I went to someone and said, does Questlove have a helmet on? And they're like, no, this is afro. This is a picture of it. I was like, wow, it interpreted as a helmet. So yeah, I think so when we talk about different cultures and recognizing that, and I think what technology can do is to make sure that, you know, our models are including people, you know, folks like to use the word diversity. I just like to say humans, that we have all human beings in there from all different ethnic groups, from all different cultures. Disability is one of those as well. So recognizing, you know, disability devices, whether they be canes, whether they, you know, wheelchairs, whatever the case may be, I think there's an opportunity for technologists to do that. That would be very helpful because, you know, we are going to be part of those images that are taken, and we being the big we, the human we. So let's include all humans.
Thank you so much.
Thank you.
We have a question from Zoom. So Donna Garari, who is the head of this workshop, asks, how do you decide whether to trust the visual assistance technology?
Ooh, nice question. Trust is, I've been thinking about a big, because, you know, trust is a big part of being blind. I'm trusting audio description. I'm trusting whoever wrote the description. And yes, I'm absolutely trusting the technology. I think when, similar to the story that I just said about the helmet, you know, when something sounds off right now, yeah, I'm gonna look for a human that I trust. And so that's gonna be my wife, my daughter, so someone in my household, if that's where I am, to inquire a little bit further. I think, you know, you have to have, usually there's some sort of, you know, I have some information. I can figure out something, right? I can contextualize what's happening and therefore think about it from that end and then interrogate further. But yeah, my immediate thing is to trust the technology. But I mean, come on, I'm you know, I'm grown. I can figure certain things out and ask questions about it. Like, I'm not going to be that. I think there was some years ago when folks were like, oh, there was a map that took somebody off a cliff. Like, come on, like, you know, if you're driving and you see the cliff coming, like, you're going to stop, like, you know what I mean? So, yeah, I think my default is to trust it at first, but contextualize and ask questions when necessary. I hope that answered that.
Yeah, thank you, Tom, as well. It's really good to hear you talk about audio description. So we've been working on that for the past 8 months or so. So getting on map Spain with researchers at Oxford, and we've been training models to generate audio descriptions for movies. But I was kind of interested in what you said about these technologies. So these models tend to have issues with hallucination and errors that, if you do anything fully automatic, these could kind of put into production, which wouldn't be ideal. So I'm wondering, someone who works in audio description, how can we help with a semi-automatic method? Would it be proposing gaps in the dialogue? Would it be identifying the character in the scene? Or like, yeah, do you have any ideas about that? So how can we do human in the loop to make sure the generations are accurate and things like that?
Yeah, no, that's fantastic to hear about. I think you mentioned character recognition. That's a big thing, because often, and again, contextualizing, sometimes I can be watching a film and it would be referred to John, and I'm like, wait, John, that doesn't make sense that John would be there. And then I find out, or if I'm watching it with someone, you know, some family member who cited, they might, that's not John, that's Bill, you know what I mean? And so some of that could probably be done with AI, but again, I'm thinking about it from the production side of the AI. So like I was mentioning, where the quality control should have picked that up that should never make it into a final version, whether that be because AI was the only thing that was used, and so someone trusted it and just let it go. I think we all would agree that it's not there. But again, taking out that human element is, I don't know, that's not my end game. That's not my end game. So being able, so again, I'm coming at it specifically from the perspective of blind people doing that work, because that I want to see more of that. So I'm thinking that interaction between the user of that technology and the technology itself is really important. Being able to ask those questions and being able to, so again, figuring out some of the additional information maybe about the difference between John and Bill, right? The difference between the characters for someone to be able to understand those differences. What is that? What makes John different from Bill? Right? Does one have blonde hair? One has, one is black, one is whatever the difference is. And again, being able to interrogate that, being able to interrogate the software. But again, it's just, I know that ability, I think that's probably easy, right? The ability to say, okay, where is there no dialogue? That seems like it's pretty easy. Am I correct?
Yeah, we can do that pretty well and transfer the dialogue. It's more just sometimes the fine-grained visual understanding is a bit weak, so someone might put a necklace in the pocket of someone, and the model will say, pull the necklace from the pocket. We were actually having a poster on it, and we kind of sort of talking through some of the work. But yeah, essentially some of the fine-grained stuff is not there. I don't know whether that might be solved in a couple of years. I mean, the plus side of the audio description is there's so much data out there because of the legal requirements. Like we found this audio on that site. I don't know.
You're not supposed to talk about this.
But yeah, there's a lot of data, so I think there's a chance to improve these models a lot. And we just have issues with movie copyright essentially. In the UK, luckily, like this for accessibility reasons, you can download the stuff, but getting actual movie frames to train model is, I think, a big challenge to these movie TV show research areas for us. But yeah, it's hard to say. Maybe the stuff will improve in the next couple of years, get good enough. But definitely a human loop for even the next 5 years, probably.
Okay. Yeah, again, I mean, my main takeaway is just keeping human beings centered in that process. And again, thinking about it from a blind person's perspective. A big part of our involvement is what I was saying, is that the idea for someone to be able to say, yes, you can. And that seems to be the toughest thing to really challenge, because some of the audio description written by blind folks today has been fantastic. Been fantastic. But we're not really going to experience that because the gatekeepers unfortunately don't believe it. So if you can keep that in mind as you're developing, I think we could do something there. And the end result is that it's going to be better for everyone, right? If you're coding, if you're making this accessible and making it work for a blind person to be able to write audio description, that's going to be a fantastic software.
Thanks a lot.
Thank you.
So I think for time, we'll need to move on, but keep in mind, we have a Q&A session with Thomas and the 2 other keynote speakers in about 10 or 15 minutes. So if you have further questions, you can kind of ruminate on them and we can ask them then.
Cool.
Thank you so much. Thank you again, Thomas. Projector needs to warm up. Sorry, I wouldn't stand up.
Now, this is the fourth and final challenge this year, Salient Object Detection Challenge. So here's the outline for this session. We will first introduce the data set and the task, and then we will dive into more details about this challenge. Then we will announce the challenge winners and present the analysis of this year's results. This is the first year we're running this challenge, and we're very excited to share the results. So let's start with introduction. Salient object detection is a task of producing a binary mask for an image that deciphers which pixels belong to the foreground object versus the background. So in simpler words, algorithms separate a foreground object versus the background in an image down to the precision by pixel. And each pixel in an image is either assigned foreground or background. So note that there is no category to the foreground objects. The objects can be anything that is identified as the foreground in the image. In this data set, images are real-world scenario images originated from blind photographers seeking to better understand their surroundings. Now let's take a closer look at the challenge itself. There are in total 32,000 images in this data set with annotations. We split the data into 3 subsets: training, validation, and test. The training and validation sets are released to the participants to run their algorithms, and the test set is used to evaluate the results at the resolution of 720 by 720. The evaluation metric here, we use mean absolute error, which we call MAE for short. To simplify this math here, MAE shows the proportion of pixels in an image that are assigned incorrectly. So that would be foreground wrongly assigned as background, or background wrongly assigned as foreground. So we have benchmarked in total 7 modern salient object detection algorithms for this challenge. And the best performing model achieves the score of MAE at 0.17, which is still 0.15 worse than human performance in MAE. So we can see there's still a huge gap between what modern algorithms can do and what human can do. And to fill in this gap, we'll release this challenge this year, and we're very happy to see great participation this year as the first year. There are in total 11 teams who submitted their results. So now, without further ado, let's announce the winners this year. We're pleased to announce the top 2 teams, starting from the second place. And the second place this year goes to Team Li from Shijian University. Congratulations to them. Their MAE score is 0.03 and well done. So I apologize if I didn't pronounce the team name correctly. Congratulations. And finally, the first place this year is Team Minivision from Artificial Intelligence Research Department, Minivision, Nanjing, China. Congratulations. We also achieved an 0.03 in MAE as the best score here. This is an amazing result that greatly exceeds the baseline. So well done to all. We're very excited to see so many innovative algorithms achieving great results. This is a huge step. And finally, let's dive into some analysis of this year's results and share some future challenges. It is very exciting to see that we're now only at 0.01 behind human performance. Now that we're very close to human, it is important that we identify what is critical for the algorithms in our data set. So we performed fine-grained analysis on the top 3 submissions to identify the challenging cases in the data set. We observed that algorithms perform poorly on foreground objects without presence of text on them. So this finding actually suggests that text on foreground objects can help algorithms to locate them more effectively. And in terms of the coverage of objects, which is the size of the objects in the image, we observed that algorithms struggles with small and large objects. And in terms of boundary complexity and image quality, we also observed that the models struggle with foreground objects with more complex boundary and images with lower quality. So all these analyses suggest that there's still much to improve, especially with images and with certain features that we are able to identify. So we look forward to future innovations. And with that, I will wrap up and go into the presentations from the winner teams.
Good morning, everyone. My name is Sun Yubo, and I'm delighted to be here today to present our work on the VizWiz SOD challenge. Our team name is MiniVision, and we are composed of Kuang Yitian, Sun Yubo, Jiang Kaixiang, and Hu Jianguo. We are from the Artificial Intelligence Research Department at MiniVision in Nanjing, China. The title of our presentation is SOD Task Solution Leveraging Enhanced Self-Reformer. In this presentation, we will discuss the methods we use to achieve the top performance result on the VizWiz SOD challenge. Here are our team members and contact information. Please do not hesitate to reach out if you have any questions. Salient object detection is a challenging yet important task in computer vision, which aims to generate a binary mask for the image, indicating which pixels belong to the foreground and which belong to the background. As shown in this slide, the box is considered as a salient object. Therefore, in the output image, the region corresponding to the box is filled with 255 to represent the foreground. In this computation, our team used 3 different datasets: the official dataset, the open source dataset, and the synthetic dataset. I'd like to mainly talk about our method to creating the synthetic data. As displayed in the figure on the right, we initially selected an image from the training dataset. Then we feed it into the blip model, together with the prompt, what is the salient object in this picture? This process enables us to predict the salient object within this image and acquire its corresponding caption. In this example, the output generated by blip was food. Then we took the original image, the corresponding mask, and the caption we got from blip, and fed them into the Stable Diffusion model. And we use its impending feature to create synthetic image data associated with the salient object food. Finally, we passed the generated image through SAM model to obtain the salient object mask for this image. This method greatly expanded our training data by generating additional examples. In this computation, our team used the self-reformer as the base model for salient object detection. You can see the network architecture here. First, the input image goes through the image encoder, which produces multi-scale feature maps. These feature maps are then sent to the global context branch to capture overall context information. These feature maps, along with the global context information, are then processed in the local context branch. The output from this branch is compared to the ground truth and used to calculate the loss for improving the network. For more detailed information about the network, please check the corresponding paper below. In the baseline, we use the original image encoder of self-reformer, which is PVTV2, and our improvements primarily focus on the image encoder component. We experiment with different architectures, including self-swing transformer, blip encoder, SAM encoder, and Deno V2 encoder. Swing Transformer has demonstrated excellent performance across various tasks, so we prioritize its usage. But blip encoder, SAM encoder, and Deno V2 encoder are all part of the VIT series, which by default cannot output the multi-scale feature maps required by the image encoder. So, to solve this problem, we borrowed the tokens-to-tokens operation from the VST network, which converts the input image into multi-scale features. The tokens-to-tokens operation is shown in this picture. Once the input goes through the transformer layer, it is transformed into multiple tokens, and these tokens are then reshaped and merged with the adjacent tokens to create new ones, effectively reducing token lengths and achieving downsamplings. By connecting multiple T2T modules, continuous downsampling is achieved, resulting in multi-scale features. The overall structure of the VIT plus T2T image encoder is shown as here. In self-reformer, the image encoder needs to output 4 different scale feature maps. Here we experiment with blip encoder, SAM encoder, and Deno V2, as they have undergone extensive training for relevant tasks, and thus will give us a better pre-trained weights. Now let's talk about the trick section. We tried out model fusion by combining the outputs of self-reformer with different image encoders. We also experiment with different binary thresholds, and finally we applied an erosion operation to the mask result. Moving on to the experimental results section. Here the term resize validation pertains to our testing on the resize validation side. We conducted this testing to facilitate bench inference and speed up the overall testing process. Although the performance on the resized validation side might be slightly lower compared to the result without it, the overall trends of the metrics remain consistent. We started by evaluating different training datasets, and as shown in this table, the official dataset gives a better performance, so we only use the official dataset in the further experiments. Then we compared the results achieved with different image encoders. Swing V2 base has the best results, since it has the highest number of parameters among all the listed models. And the last 3 rows display the result obtained with the VIT architectures. Deno V2 stands out, leading us to choose the larger Deno V2 VIT large as our image encoder for further experiments. Let's take a look at the final result of our method on the test dataset. Our method achieved an impressive IOU of 0.94 on the test challenge dataset. Finally, our method outperformed all other teams, earning us the first place position on the public leaderboard of the VizWiz SOD challenge. Thank you all for your attention and support. Have a nice day.
We have the video from the second place team.
Hello everyone. We are a graduate team from Xidian University IPIU Laboratory, and it is a great honor to share our scheme in the CVPR object detection competition with you here. After preliminary data processing, the data set contains 90,116 training set samples, 6,105 verification set samples, and 6,779 test set samples. In our preliminary analysis of the data, most of the CVPR targets occupy a large pixel distribution in the figure, but at the same time, we also found that among the parameters of the dataset, there was a parameter named EXIF that would cause the abnormal angle of the image when loading, so that it could not correspond to the mask. Therefore, in the processing stage, we cleared the EXIF parameter to prevent the occurrence of anomalies during training. In addition, we made some extensions to the dataset, adding 4 additional datasets to enrich the training set. combining these datasets with the training set and the validation set of the competition's dataset, a total of 51,721 samples will be obtained. Due to time, only the thematic segmentation network of mask former was selected in this competition. The specific reason is that its mask segmentation method is very suitable for the concept of cellular target detection in our opinion. At the same time, we used these data enhancements in training and forecasting respectively. At the same time, in the ablation experiment, we found that the cutting size should not be less than 80% of the maximum size. Otherwise, it may be difficult to converge. We judge that the reason is that it may lose the significant target samples, thus confusing the network. In the prediction stage, we adopted the method of voting to obtain the final result. Firstly, we tried the two models and 512 and 720 resolution respectively, and adopted the EMA strategy to obtain two EMA models. For these models, the scaling scale of 0.5, 0.75, and 1.0 of the training image scale were used to make multi-scale prediction. Two models predicted at the same scale were hard-voted to obtain the prediction results under different resolutions. Finally, we will make the intersection of the masks predicted by the two scales to obtain the final prediction result. In the end, we got a score of 92.91, which we attributed to the following schemes: expanding the dataset, choosing a suitable model, adopting a reasonable training scale, adopting a multi-scale prediction, adopting a hard voting scheme, and finding the intersection of the final results. That's all we shared this time. Thank you for listening.
Thank you to Talk to teams for sharing your algorithms for such amazing results. So this wraps up all the challenges this year. Thank all teams for participating, and let's move on to the next session.
All right, so our next session is our Q&A panel with our keynote speakers. So if I could invite Thomas, Eric, and Lauren up to the table here. Take just a second to get set up, and then we'll get going. Go behind this podium, behind the podium. Do you want to stand there? I'll grab some chairs. If these chairs move, do these chairs move? They're like they walk together. We want to actually, that's a good idea. Sorry. Okay, we are going to put some 3 chairs here in the front. Yeah, good idea. Yeah, although we don't save the paper slide. Okay, well, we can use. Should be. Very. I didn't know if the audience would have Thing. It's just a little bit. Let's get rid of the owl. Just do this. Good. Thanks. Last thing. Thank you for putting them. Okay. Still getting this on here. Big audience that we have for this section of videos is afterwards. So all right, I think we're good. Ready for the panel? Did we people confirm everything seems fine? All right, so again, one of the really fantastic things I think about this workshop is that we bring so many different perspectives together. And so our three panelists are sort of the embodiment of those perspectives from our user perspective, research perspective, and products perspective. I wanted to touch on something that I thought was a theme across all of your talks, which was in different ways, you all touched upon kind of the errors that AI can make. And I think that maybe there were different approaches that we talked about in terms of how we might address those. In terms of research, I think you talked, Eric, about kind of changing the algorithm, developing new algorithms. I think in Warren's talk, you talked a little bit about sort of almost like the design perspective, like how do we turn what we can do and how do we think about what we need to address turning into product. And then Thomas, I think you also had a great perspective of we need to be involving users in making these decisions. So I thought that if you want, I thought all of you, maybe with that little bit of a prompting, I could call all of you on the spot, think about not only how do you think about errors, but from this session, these sessions that you just enjoyed, is there how do we think about this going forward, especially as models get more powerful, larger, things are kind of getting more complicated. That's too nebulous. Well, Eric, start to my right here. We'll start with you.
Yeah. Okay, so I think I learned a lot from this workshop, especially from Thomas and yeah. And so, usually when we listen to the reports, then we talk about once algorithm and bad results. And even when we talk about fairness and trustworthiness, but they are mostly from the research side. And for example, when I viewed visual question answering in the past few years, I felt like this problem is mostly solved. Like it seems like the accuracy is not increasing that much, but from Torrance point, I did learn that, oh wow, there are so many lower challenges. When you apply those technologies onto the real world, like exactly like the 20%, it might be the hardest to achieve, but that's exactly what we should work on. Not only engineers or in but also the researchers. And speaking of the advances for blind people, then I think we all realize we need to talk with any user like or visual impact. Yeah, it's really
Thomas, would you like to add anything?
Sure. I was thinking about the question in terms of the track and what about another example? So I guess I think that there's a level of, I think I'm in context, but there's a level of responsibility, I guess, that the user has as well. So for example, sometimes I might be looking for, let's just say a pair of socks. And I take a picture of it to determine, are these white socks or are they black? I'm not that fancy with my socks. Those are only two. White socks and black socks. And so occasionally, and I realize because depending on where and how I take the picture, there could be some reflection on the front of the mirror. There's a reflection involved, but the answer that I get might say something like gray or brown. Well, in that case, those to me are probably my black socks, right? I can figure that out because they're darker socks. So the technology isn't perfect, but I got the information. I was able to get the information that I needed. So there's that level that as a user of the technology, I have to sort of bring it. Now, if I was a really exotic sock person, that might not be good because I probably would have a bunch of different colors. And so therefore the need for me to be exact might be different. So in that's a sort of silly example. I think there'd be really examples where I'm not going to trust the technology as much if it was, medication. And unless there was something that I know is that, you know what I'm saying? So I might not take that particular medication because now I'm not sure. Is it ibuprofen or is this something stronger? So I guess I just think about it in terms of what I, as a user, like what's my part of this quote unquote contract that I think is that we have to think about. Whatever we are. You have to think about it.
That's a quick follow because I'm super curious. I think we worry a lot in this kind of field of study about people being accidentally misled. And so I think what your perspective is very good one, which we shouldn't think that people are just going to naively drive off, because they have to take some responsibility. Are there cases that you think might be more subtle, where technology could mislead, or we could actually maybe there's a way to approach the design of the technology so it's less likely to mislead?
Less likely to mislead. Don't know. Again, I think we're thinking really specifically, right? Yeah, I don't buy it.
Yeah, no worries. It's hard question. I think it's one we're grappling with. But maybe actually, or maybe well, you don't have to answer that question. You can answer the original question if you want, but did you ever?
Yeah, let me answer the original question. Then let's think about it. For your initial question, I think AI models, it will make mistakes. We will never change it. No matter how far away the technology evolves, there will be mistakes. But the problem is, how are we thinking about these mistakes? And one particular area I want to talk about is about AI fairness. Like probably 5-10 years ago, this was not a very hot topic. People didn't pay too much attention in this area. But recently, especially within these maybe 3 years each, this is growing hotter and hotter. People are indeed paying attention to this. For example, in our product, we want to add some description for people to describe if this person, how old this person, and the perceived gender of this person, and the clothing wise, everything. And we have to go through a very complicated review of all of this information. Even for some features, we think they may be very safe. For example, clothing. I can say this is a t-shirt. It sounds really safe, right? But in reality, in some different places, they may have different religions, different cultures, and you have to use some specific terms for specific clothing, and which could be problematic. As a product team, sure, this gives us a lot of hard time to release our feature because every feature it needs to go through a bunch of reviews. We need to prove, we need data to prove like this is fair, this is reasonable, this doesn't harm any like any culture, any region. But still, I think this is the right thing to do. So back to the original question, what do I think of errors? I think error is actually sometimes good thing for us to pushing the boundary of our technology and to make our technology more responsible.
Yeah. So I love the fact that the technology is also sort of maybe with the technology I'm thinking about it is cultural competence, right? And so we talk about that all the time. Well, in audio description, like that's so important because technology is, yes, and human beings are still struggling with being culturally competent. Like we need to not only respect culture, but also to understand what you don't understand and understand the need that you might need to do that research. So is this a t-shirt or is this something else, right? Like, it's not the either that y'all are struggling with. Very important thing.
And so the audience, feel free to also ask questions. I can keep continuing discussion, but come up to the mic if you'd like to ask a question, or if you're on Zoom, I think I could see someone type something. Oh, someone type something. Okay, perfect. So this is primarily for Thomas. I would love to hear a dialogue on how can we design solutions that end users can or should trust.
I mean, how can we design it? I think it's about taking everything that we're talking about into consideration, right? Like there's that level of research, there's that level of cultural competence, there's that disclosure in the beginning to let people know what our responsibilities are as the technology, as the consumer of the technology. And I think also a big part of trust is the response to the community, right? So when a community is saying, whether it's we labeled our stuff incorrectly, well, how do you respond to it? Because it's just like a human relationship. If I tell a loved one, I don't like it when you did that, right? Or I have a problem with this, and it's continuously done, then my level of trust that this is, that you're taking me into your consideration is going to go down if I don't see any sort of result. I think that's a big part of it. It's a relationship. We have a relationship as a user base and a technology company that needs to be treated as such, as a relationship. I can't go into the technical details of what can be done, but I think thinking about it from that perspective as a person, what you would want in terms of how you think about trust. And I'm just going to go back to what I know. Contact.
And that's really great. I guess, all right. How do you think about that? Do you have processes for incorporating user feedback? Have you gotten a lot of, to the extent you can talk about it,
Yeah.
How does that work?
Yeah. So in my presentation, there is one thing I said, like, it's really hard to get something like work 80%, but it's really hard to get a direct 20% done. We have a bunch of those features. They are still like under development. Basically, it's not working. It's working like for 80% of time. But still, we want when we release some features, we want it to work for most of cases. We don't want like our users to come to us saying, okay, look how it doesn't work in this XYZ case. So we have a really high standard on our product. That's also why like you can probably see like Lookout doesn't update quite often, but whenever we update, we are sure, like at least 90% sure, like our new feature will work for everyone or like for most of the use cases. Yeah, so I think that's a standard we need to keep in mind for the product.
Eric, I have a question for you related to this as well. Obviously, we can address the general topic of trust. I guess I wonder, part of trust is building this relationship and kind of responding to feedback. Do you have thoughts on how models can or already do allow for, say, changes or personalization or however else you might interpret this human feedback that you get?
Oh, yeah, so, recently, our lab is in a new key, we are fast challenges, where, we obviously developing tools that can probably be working with those who come from the Wi-Fi, social, animals, and for that, we are incorporating the human user feedback into our model design and model development. So, and generally, even for ChatGPT, feedback is not of that it's still some blind spots. So, I think, from technical perspective, reinforcement learning or human learning or human learning in the coordination to address this. And but meanwhile, I think it's really essential to have interactive learning, right, which can incorporate those human data in a format.
So I guess one good question I have. So one thing I often, the perspective I often take with technology development, including assistive technology, is one where I like to think of, well, what are the people going to be doing in this future that we might imagine technology could be? And I wonder if you could all take a little bit of time to think about it and then immediately respond without much real reflection. Wonder if you look forward 5 years from now, each from your own perspective, given some imagined progression of where your vision and artificial intelligence will get us in 5 years, what are the people going to be doing? And so, in particular, I'll go back just in order so you a little bit of a breather. Thomas, imagine that in the future, in 5 years, computer vision, AI has progressed a lot. What that means, up to you. What will people who are blind be doing with it? How will they be interacting with it? What will change or not?
I think that kind of goes to what I was talking about. My hope is that it would lead to more net access to independence. And so my whole thing, and again, knowing that that is different for everyone. But I think a lot about, again, that level of unemployment. So, I mean, it's a fact. It's 50 to 75% unemployment within the blind community. That's nuts. That's nuts. And so I think one of the things, when we talk about AI, there's this sometimes there's this idea that at some point in the future, people can just live and we don't have to work. That's not going to be our life, right? So I think there will always be a need. And I think people want to work, people want to live their lives. So my whole thing is that the technology would really enable. And again, some part of that is that's all the technology, but it would just be fantastic to be able to have access to the thing we want access to, just like anybody else, with some anonymity. I think anonymity is a really good thing. It's something different when you have to ask people for X, Y, and Z than it is to just be able to sort of seamlessly do that and access that information yourself, and then do whatever it is that she wants to do. So if it is employment, if it is access to spiritual information, if it just makes your daily life better, if you're a baker and you can just now independently access things that you need to do to bake bread, then that's progress. because you're just able to live your life. You do it.
Great lead in potentially for you, because I was going to ask you, what products are you going to be developing? It sounds like, I mean, Thomas has great ideas here,
Yeah.
What will you be doing? You'll be, 5 years from now, you're at Google, let's say, and you're working.
Yeah, that's a good question. So should we like make sure all of I'm saying below they are like my imaginary. Oh, I don't know like if any of this will be true, but I'm thinking maybe in 5 years later I will be a lookup user. It's not because like I will be blind or whatever. Is what if we can make lookup work or useful for like even people like me, or like you, like just anyone. For example, now we are talking about VQA, we're talking about the image description, everything. Saying I'm going to a museum and there are maybe some paintings on the wall, and I have no idea of those paintings. But with wearing glass, and then I can use the glass, use the glass camera, and then ask Lookout, okay, Lookout, tell me more about this painting. And then it can just tell me like who paints this, and maybe some stories about it. And then I can walk around the museum to see like more information. And maybe it can even guide me to other paintings this artist painted, right? And another case, maybe when I'm at home and I want to do some cooking, and I grabbed some things, materials, I don't know how to cook, and then I just look up, okay, tell me how to cook this. And I think in 5 years, we have a good chance to make all of this work. But so at that time, I may be a lookout user by myself. Yeah.
Right. Well, accessibility often leads the way, as we would say, and so I think this idea of kind of just pervasive access and understanding of visual information, and then incorporating that into daily routines in whatever way makes sense. Makes a lot of sense. Eric, what are you going to have to do? What are you going to do to make all that possible? What are you going to be doing? Are you going to be out of the job in 5 years to solve all the research problems?
I don't know. I think some things is describing very happy. And ask AI assistant to very helpful. But in 5 years or in 10 years, I think it could be more like collaboration between humans and AI. So right now, some AI tools may not be that necessary for some human users, but in 5 days, the AI tools would be necessary for probably all human users, and they would be more and more personalized. And then the human AI collaboration is really important that it would not be just like me, human guiding AI, for example, or AI instructing human in lots of domains, which would require the joint decisions between human and human. So it's really essential to that humans and AI systems should understand each other's strengths and weaknesses. So you can imagine a personalized portal for many users, and which understand this particular user's strengths and weaknesses, and then human user can use this AI portal to do lots of things. So like for people with disabilities, then the AI could play an inconvenience for human users. Human users can be qualified for lots of jobs that cannot be done by such. So yeah, I really agree that in the future, the long run, AI could play a essential role in lowering the accessibility. So yeah, I'm positive about AI. So yeah, but of course we should be aware of the risks.
Yeah, go ahead. We have one question after you. We'll have one question on Zoom.
So there's been obviously a lot of vision classes over the years. Do you think the newest devices like the Apple Vision Pro, is there still a missing ingredient, or does the LiDAR scanner and the stereo cameras and all that stuff sort of, what else do you think would be needed in that sort of part of the solving? Whatever you'd like to take.
I can start. But to be fair, because I'm an employee from Google, it's probably not very appropriate for me to talk about a product from another company. But from my personal view is, I think for the wearable devices, the two major constraints are one is the battery, and the other one is the computational power. And I don't see the Vision Pro by myself, so I don't know. But I'm wondering how good it could be on these two cases. If if it only works for 1 or 2 hours, then it's not that useful, right? We need to keep improving on those. But we will see. I still don't know too much about that.
But personally, I'm very excited about the Apple Vision Pro, but certainly right now, I don't think most people have the access to it. So we are still only seeing the demo, and so I will need to wait for the real product. I will check out. I like in terms of the access at price point as well. Access is working. Obviously, that comes down, not going on, but that's always a working when it comes to any sort of technology. That whether it be specific to people with disability or not, that's and it seems like even within the blind community, there's the haves and the have-nots, and to have a subscription to something like Ireland, it's certain dollars when it comes with, but it brings with it some incredible access that I think everyone really should have that question. So I think it's the same thing. Yeah, I don't know that much stuff.
Repeat the question on Zoom here. So Donna, love to hear Eric's thoughts, particularly given his work on counterfactual prompt learning work. Is there evidence that the model does a better job in reasoning based on the visual evidence and the image rather than other spurious correlations? And I'll save the rest. Did I capture your question? So is there evidence that the model does a better job in reasoning based on the visual evidence in the image rather than other spurious correlations?
What's the question is how the counterfactual prompt learning method and improve the results based on multiple features. I'm a little bit confused about it.
We're gonna give Donna a second to maybe help us clarify. One follow-up, Tom. So I have a question. So there's all kinds of different headsets that have been out there, almost like head-mounted cameras and everything else. I was wondering, do you have thoughts on what would convince you? Let's say it was affordable by some definition. What would convince you to actually wear them? What would be the? Is there a killer app or something that you would think, yeah, now it does that, so we're gonna wear it?
Well, there's that. I mean, there's some of the stuff I would really like. I like it. I'm used to it. But again, if there were glasses, number one for me, glasses have to really fit my face. There's not many that fit my face. Okay. And so there's that. But there's the othering that happens with technology. I remember years ago when folks were making use of the GPS before we had it. And it involved you having a laptop or a device the size of a laptop strapped to you on, as well as this other GPS sort of receiver. And there's some headphones, and I'm like, I don't want to walk around like that. Like there's the othering aspect of some of the technology. And again, I know it's a project, it's a progressive thing. Takes a while to make it small. But no, I mean, I think some of the technology is fantastic. Like I'm a big fan of indoor navigation. They work wonderful. Like the ones that I've used. And so I would consider definitely getting glasses, especially now that they have the phone conductive audio. I would consider as long as but it has to look good. I'm a little vain, but I guess it's just I'm already standing out, right? When you have the white beam, you already stand out. I don't think I need the icing on me to make me stand out.
And then, oh, I guess there's a follow-up question. So, Thomas and Horan, Donna was wondering, is it important that models reason based on the correct visual evidence? And you could kind of take that in a few different directions, I think. But we talked, Eric talked in this talk about how models sometimes, make mistakes because they sort of make up things that don't exist in images because of correlation somewhere in their data, so the visual evidence isn't there. A lot of times, actually, that can maybe be useful in certain ways, right? Because it actually is pretty likely that if something's catching a frisbee in their mouth, it's not a human, it's probably a dog. So maybe you can't see the dog. So how important is, I guess, that how important is it that the model is reasoning based on correct visual evidence?
Yeah, we have this issue with the image Q&A feature as well. We internally we call this like the model illusion, or if I remember the name correctly. Basically, is the model will make up something about a question. For example, if I there is a picture of a human, and I just ask how old is he? Maybe it's just a back. The back of this person. So the model has no idea how old this person is, but the model will say 48 or some number. And there are some other cases there is no reason why this model will give that result, but the model did. And from a product perspective, we think this is a bad experience for our users, because think about it, for blind people, they will probably use lookup as a ground truth. So if we give them some makeup information, then they won't be able to trust lookup anymore. So we'd rather to give user consensus but accurate information rather than this maybe some illusion.
It's funny that you say made up information, but it's making me think there's an app that I use for that. I took a picture of myself and it described me as a 34-year-old man.
Hey.
Important. Fantastic information. So you can make that up already. It was quite interesting. So I think the reason why the model often information because we're not the vending cells, the models tend to exactly the skills situation. So it doesn't only capture the skills purpose, but also exactly. So that's why it's very important to do contract for these kind of alternative scenario that wouldn't be observed in the feedback.
We are really out of time, but I have one last question, and hopefully be quick, because I'm going to ask you to keep to a sentence, because that's the random challenges are fun. Okay, so here's the challenge. So we've talked about all of this fantastic progression that we've made, all of this progress. And we talked a little bit on this panel even about some of the things we might see in the future. I wonder if you could kind of take it back. Like, what's the biggest challenge you think that we're going to need to solve in the next 5 years to make some of the better outcomes we've talked about actually come true and avoid any of the negative ones to worry about? And I hesitate to pick on anyone, but now I'm giving you a bunch of things, got to make up an answer, make it short.
Actually, I'm ready because it's already in my slide. In the last, I think the last 2 slides, I said, let's try closing the gap. Because I see this gap between the technology and actual product is probably will go increasing over years. For example, the VQA model, like generative AI models, they're powerful, but they are also expensive, they are big, and it's hard to make them, all of them accessible to everyone. And how can we close this gap? How can we make sure that all the new technologies we build, they could be accessible for everyone? They are built for everyone, not for some elites, just for some researchers. So that's my point. Let's try closing the gap.
So I guess the thing that I would just say about it is center. I don't know whether, I don't know how, but you center units and local. I think that's an important part of the government unit. And technology trustable, usable, relevant to all involved. I think for the development, we have to arrows, like in very early stage, we do symbolic life, but it's no learning at all. And then keep learning first life, and then we spend a few years to focus on model-based learning. And now it's more like data-driven learning. We still have data and the model science to do lots of incredible things. In the future, we focus on human-centered learning, including the personalization we talked about and the human AI evolution. So, on my lab, I would focus on human-centered learning. So I guess we should this is human.
Yes, well, thank you so much. You heard it right here. 3 biggest challenges are closing the gap between like the best performing models and what's easily accessible to everybody, keep things human centered, actually making all this progress while keeping trust in systems and keeping things at the human experience at the center of it. And then how do we actually enable that visualization and that deeply personal human technology that we all think is probably needed. We don't really know how to do yet. So that's the conclusion of our panel. I want to thank our panelists, our keynote speakers again. And do we have any poster presenters here in the room? I think there are no poster presenters, at least in the room, and maybe at the conference. Is that true? Possibly? Okay. So then I think we're actually done. I'll turn it over.
You will be doing the closing remarks.
Closing remarks. That's what I thought I was doing. Okay. Right. We have closing remarks. Okay, thank you, panelists. We will very quickly
to tell the project.
All right, there we go. Okay. So the actual closing remarks. So thank you all for attending the VizWiz Grand Challenge workshop. I've had a lot of fun talking with all of you, and I really hope you just see how unique and wonderful this workshop is in bringing together so many different perspectives, all clearly relevant to the topic of the workshop, but I think very different than you might see in a lot of workshops here at CVPR. So most importantly, we want to thank our invited speakers, Eric, Thomas, and Horan. Thank you again. Thank you. We also want to thank the VizWiz users who used the app and provided data that we are still using to improve computer vision for this important cause. We also want to thank our crowd workers, the workers who labeled our data, helped annotate it to make these challenges possible. Thank you. We want to thank Eval AI team for hosting the challenges. So without that, we would not be able to set up competitions like this to help people kind of work on better and better solutions for these challenging problems. So thanks, Eval AI. And thanks to the organizers, especially Changyan and Yiyan. I want to thank you for coming and helping make all of this actually happen. And of course, Donna for being mastermind, Ed, who did I forget? Daniela, Abigail, Simreen. Thanks to all the organizers. So that is, I think, almost the end. Of course, this is our 5th. Who knows what we'll be doing in 5 years? But no one asked me, right? But probably having the 10th annual VizWiz Grand Challenge, although I imagine it'll be a little bit different even in 5 years. So if you have any feedback, please let us know. And I hope to see you all around the conference and have some more discussions and see you in the future years. Thank you. Wait, there's chats. Oh no. Good. Notice your